the capital of Nagaland, a mountain state in eastern India. Its length is 60 kilometers. Every day, thousands of cars pass along this road. Old and broken asphalt had significantly reduced traffic capacity, damaging cars and slowed down traffic speeds. Economic development of the state required the construction of a new modern road. It was decided to build it using A&T stone roads technology. Construction work was carried out without stopping any traffic, whilst maintaining high quality using our new technology. The first stage is the creation of a sub-base layer of the road. It requires only 4 components: soil, cement, water and A&T soil stabilizer. Waste from a local quarry was used in the construction, including soil from the surface of the mountains containing clay, sand and stones of various sizes up to 40 millimeters. The ready mix is prepared in a mobile soil mixing plant. 4% of cement is added to the soil. After that, the material enters the mixing chamber, where an aqueous solution of A&T stabilizer is doused onto it. At the same time, the stabilizer composition rate is 0.007% by weight of the soil, and the quantity of water is calculated based on the optimum moisture content during the compaction. The preparation of the aqueous solution is carried out in an additional tank, from where it is pumped into a mixing chamber with a metering pump. Note that the A&T stabilizer is environmentally friendly for humans and nature. The finished material is transported onto the road in order to create a new groundwork base. Work is carried out in lanes, first paving the first lane with a 100-meter overlap. The paver distributes the soil mixture, taking into account the required slopes and layer thicknesses required. Then the roller compacts it into the required density. The density is continuously monitored during the process. Immediately after compaction, a new section of the road can be opened to traffic. It does not require any additional care or adjustment. Then the paver moves to another lane and continues to create the sub-base layer of the road. A&T technology can significantly simplify the construction process and shorten timescales. Here you can see a stone road built a few months ago. This is a monolithic stone slab without cracks or deformations. Sledgehammer hits can fully demonstrate the strength and elasticity of the stone base. The modulus elasticity of the stone foundation significantly exceeds conventional construction procedures. This formation also allows the road to be used for decades.
मारिए एकदम कस के, जितना दम है और जितना दम है मारिए। अरे भाई और तेज मारिए महाराज, मारिए मारिए और तेज मारिए। रुक जाइए, हो गया, बस 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 मारिए। रुकिए रुकिए, इसका देख लीजिए।
The final stage is the creation of a 4-centimeter layer of an asphalt concrete coating and the application of road surface markings. Let's take a closer look at the differences in the technologies. The initial construction of the road was as follows: a sub-base layer made of an optimal sand and gravel mix with a thickness of 25 centimeters, an asphalt base layer of 5 centimeters, an asphalt surface layer of 4 centimeters. A&T Engineering's technology using the new design, a stone slab made according to the A&T Stone Roads technology with a 20-centimeter layer, a 4-centimeter thick asphalt layer. This allows for a saving of more than 25% of the road construction costs by reducing construction time, material costs, fuel and electricity, as well as labour costs. The application of the A&T Stone Road technology made it possible to build a more solid and therefore longer-lasting road. The stone base can be used for decades, which means additional savings in the future. In addition, the use of A&T technology has reduced to a minimum the environmental damage to one of the most beautiful places in India.
Board KIIFB. We will be starting today's session on the topic Evaluation and Performance Monitoring by Sri UK Guruvitar. To introduce the speaker, I would like to invite Sri Chandrapradap R, Scientist, NATPAC, to the dais.
Sri UK Guruvital has retired as Chief Scientist at CRRI. He was head of the Geotechnical Engineering Division in CRRI for 3 terms. He has more than 35 years of experience, and he has worked in various fields of highway engineering. He has published and presented more than 100 R&D papers in various national and international journals, conferences, and seminars, and authorized over 75 technical reports. I welcome you, sir, for the presentation.
Hello, check. Hello, hello, check.
Hello, a very warm welcome to all of. This presentation I would be making sitting here. Please don't mind. Actually, the presentation is entitled "Evaluation and Performance Prediction of FDR Road." We all know that the FDR technology is very new, just now being introduced in India, and how we don't have much information, much data on its performance. So what I am going to present to you is a kind of standard operating procedure, SOP, that can be adopted for this evaluation and performance prediction of FDR roads. Actually, it is a kind of a generic procedure I will be presenting with some specific references to FDR. This kind of a generic procedure you can adopt for performance evaluation of any type of new materials, any type of new technology. So this presentation, I believe it will be more useful for this faculty here and research scholars here. And of course, to PIUs also, implementing agencies also, because majority, every road you have to monitor the performance. You must be knowing what is the way. So that's why. Thank you. We will go. Now, this is the broad outline of the presentation: planning, then the field data collection, modeling, life cycle cost analysis, and report preparation. Next one. Next. Starting, how do we go ahead and plan our performance monitoring? Of course, you all know what is a distress in the pavement layer. Changes in the pavement layer materials manifest as distress, and distress affects serviceability. This is fundamental thing you all know. Performance monitoring is basically determining the serviceability levels. Serviceability levels we define in terms of comfort for driving, comfort for riding, economy, fuel savings, and also, of course, the safety. Safety aspect, I will not be touching it here, because whatever the type of payment, whether it is FDR, whether it is with any new material or conventional material, that mainly depends upon, of course, to an extent it depends on the material, but to a large extent it will depend on the geometrics of the particular road. So that's why the other aspects I will be confining to. Comparing performance evaluation, performance of road sections having FDR technology with the conventional road section is what we should do. A new technology should be technically viable and economically feasible. It can alter structural or performance evaluation, functional performance. Performance is of 2 types, structural and functional. You all know that. So whatever the new technology that we are adopting, it should be technically viable, self-explanatory, and economically feasible. And using this new technology, we may have an entirely different regime of this functional and structural performance. It may be similar also, but it can be different also. Now, how do we deal with that situation? So actually, we have to undertake long-term monitoring. We have to undertake long-term monitoring. Long-term means at least the design life. So design life for PMGS5 roads is 10 years for the flexible payment, 20 years for the rigid payment. So we have to monitor for 10 plus years. That's what we call it as long-term monitoring. But worldwide, they have done few long-term monitoring studies. If it comes to highways, it will be even more, 20 years, 25 years like that. Worldwide, they have done it. But if we do it, it may not be economical, and we want the results quickly also. Any new technology, we want to evaluate quickly. Next one. So that's why what we should do, what we supposed to be done. So this is the broad schematic view for this performance evaluation. The first three squares, they are with planning, designing different combination of payment cross sections, identifying the road, then the construction of these test sections. So this is with the planning and construction. Then the performance monitoring starts. The first cycle is, of course, we have to do structural as well as functional performance evaluation, I told you, and visual condition survey also. Visual condition survey, it depends upon both these aspects, structural as well as functional. And monitoring the test sections and control section before and after monsoon. This is very important because just before monsoon, the moisture content in the subgrade soil will be minimum. And just when the monsoon is about to conclude, the moisture content will be maximum. The subgrade bearing capacity will be maximum before monsoon, and it will be lowest when the monsoon is concluding. So that's why these two periods are suitable for performance monitoring. But nowadays, as you may be knowing, that a lot of changes in the pattern of rains is there. Many places it rains for very heavily for few days, then there is no rain for many days. Once again, the rains resume. So this kind of situations are there. I don't know with regard to Kerala, you might not have experienced that much as maybe inside these plain areas. But these aspects are to be kept in view. And next thing is that everywhere the onset and conclusion of this monsoon season, it varies. And it is different in Tamil Nadu, it is different in Kerala. So these aspects are also to be kept in view. Then of course, we may monitor for about 3 years, 4 years or 5 years. That's the optimum period. And during this monitoring period of about 5 years, once or twice, at least once or better twice, we must go for this traffic and axle load survey, test pit analysis, test pit observations, laboratory testing of the field samples, including the course, etc. Okay. And we have to collect the climate data also. That will be useful if there is any premature failure because of this unforeseen, unpredicted, this extreme climatic events like cyclones, etc. So if they lead to failure, we will be able to give a satisfactory explanation. So this before monsoon and after monsoon is to be repeated every year for 3 to 5 years. And once we are ready with the data for about 3 to 5 years, we can go for performance prediction because the service life is 10 years. So we have to predict when it is going to deteriorate based on whatever we have already collected. We have to predict how and when it is going to deteriorate to an extent it requires overlay. Not just the routine maintenance will be sufficient, but it requires an overlay. Normally, the PMGS5 roads, NRIDA specifies that for conventional roads, after 5 years, you have to go for an overlay. Will we, if we use this FDR technology, will it be required after 5 years? Or can we postpone it to 7 years? If you can postpone to 7 years, that would be the best option. Or most unfortunately, will it require overlay after 4 years only? So these are the questions we don't know. Answers to these questions we don't know. So to get answers for such questions, we have to monitor it for a limited period of 3 to 5 years. And then using the data, we have to project it. And once we know that for entire life, entire service life, 10 years or so, so what is the maintenance and this rehabilitation strategies required, we can come to the, we can calculate the life cycle cost. Next. So data to be collected, structural performance, functional performance. Structural performance deals with the strength of the pavement. Functional performance deals with how smooth our pavement is there. Pavement distress condition survey. What are the distresses that are manifested in that pavement? Visual survey will be the best option. Other related data like climatic data, traffic census, axle load survey. These traffic sensors and axle load survey, they are interrelated. They should be interrelated, interconnected. Test pit observations, material sample testing in the laboratory, drainage survey, and maintenance data. So these are all the other data which will be required. Frictional characteristics and noise generation are not considered for FDR roads. That also I have written. Frictional characteristics mainly deals with the wearing course. So for FDR roads, we are modifying the base course. Existing pavement is there. We are recycling it, making it into a stronger base. And above that, of course, the black topping usual we will be laying. Even if a conventional road is there, black topping will be there. So that's why frictional characteristics may not be necessary. That's what I have. I feel like that. If you disagree, you can tell. Noise generation. Noise generation is especially important if you go for a blacktop pavement or a cement concrete pavement. In case everywhere it's the blacktop pavement, the noise generation will be almost similar. That's what we can assume. And moreover, these are PMGSY roads. So that doesn't mean that the people who live in the village areas, they should be disturbed by noise. But it noise, whatever the noise generated in such regions, it will be very well distributed. So these two are not necessary, I have written. Environmental monitoring on a case-to-case basis. That's what the important point I have written last. This is because we will be using a new material, new type of a binder, and whether there will be any effect of leaching from that binder. That needs to be, that is what is required to be monitored. But the issue is that before using that binder itself, we will be testing it in the lab. We will be ensuring that it is safe to be used. Not that once we go ahead with the road construction and then we start thinking about how the environment will be affected by this material. So that's not the way. So before that itself, we have to do that. And even after ensuring in the laboratory that it's a okay material, it's a safe material, then also maybe of course, if it is needed, we can go for environmental monitoring, and that's an optional, I believe. Next one. Selecting the test sections. So there are two aspects. One is a test section, another is a control section. Control section is a conventional road section selected for comparing the pavement performance. Test section, it relates to FDR road, restricting the number of variables in the test section. That means in a test section, we can vary the percentage of additive. We can vary the thickness of that layer. So the number of variables can be there. But to get accurate data, to get reliable data, we must restrict the number of variables in a particular test section. That's the idea. Identification using GPS and Chinese. What should be the length of the test section and control section that I have written there. Minimum should be 250 and above. If it is between 500 to 2 kilometers, that would be the best. Next one. Factors to be considered while selecting such test and control sections. Geometrics, like you, for example, you have seen just outside. Of course, these are all, I believe, roads which have been inherited since the inception of the when this city or town was getting formed. So you might have seen that whatever the gradients are there in many of the roads, it's almost 6%, 7%, I believe. I don't know, I have not measured, but very high gradients are there. If you have a test section, if you have a control section in such an area, definitely water logging problem, such type of issues you will not definitely get. So it is better to avoid such sections, straight sections without much curves or steep gradients. That's the best one. But many times it may not be entirely feasible. So we'll have to keep that factor also in mind. Traffic to be same for test and control section, obvious. Subgrade uniform across the test and control section, that's also obvious. Climate, we must, of course, nowadays even private climate monitoring stations are also there, like SkyMet and all. We can get data from them, or we can definitely get the data from Indian Meteorological Department, IMD, and we can have our own weather recording stations also. That will be useful, that will be required if you are doing it in a hilly area. Like, for example, I'm not very well conversant with the hills in the south, but in the Himalayan region, there will be the climate, the weather will be changing entirely differently if we are traveling in a hill road. So there we can have this kind of a recording, automatic recording station. Drainage, water stagnation, if any, widening involved or not. So that is also another important issue. It's not advisable to have a test section in a widening area and control section in the same 3.75 meter wide section like that. So that will be, that will not be, that's not a good practice. Next one. Now, typical layout of the test and control section, I have just given a schematic view. The blue color represents the control section, and the gray color, it represents the test sections. So many different sections I have written there. Control section, of course, it can be one type, two types, three types also. Or maybe control section 1, we can compare the performance of an FDR road with a granular pavement also, but whether it is better or whether this one is better. Or we can compare the performance of this FDR section without the bound layer, with the bound layer, but without the additive. So like that, we can have a combination of test sections, and of course you can be using a SAMI layer. We can have a SAMI layer control section and one with this granular interlayer, the control section. So different combinations of the control sections will be better we can be having. And for the FDR section, we can vary the dosage of the additive with and without SAMI, varying the pavement thickness. So all these options, of course, we are going for a very high, very strong, high strength pavement. Just like just now you were seeing that video. In that video, that person, the laborer, was hitting the pavement with a sledgehammer, and it was not getting affected. You would have seen that video. So in such a case, can we reduce the pavement thickness? Can we go for a thin layer? So these are some of the issues which we don't have answer. And normally, this whatever I have suggested is for a road that has been particularly selected for performance monitoring. Otherwise, we don't go for these kind of variables. It will be a single throughout the road, whatever the sections are there, because it will be easier to construct, also easier for administrative purpose also. So that kind of a sections also we can monitor. But if we vary and if we take this kind of different test sections, we would be having very valuable performance data. That's the important. So that is for the PIUs, the implementing agencies, to think and act. Then, of course, the transition zone in between, whatever the payment section for the transition zone, we can decide judiciously. And the lengths of them I have given there. Next one. Duration and periodicity of monitoring. The distress is caused by traffic loading and environment. Long-term monitoring, I just now told you that it's a costly, delays drawing conclusions about the efficacy of the new technology. So that's why 10 years, 15 years monitoring is ruled out, at least for these PMGSY roads. We can go for 3 to 5 years. Optimal duration, I have written 5 years, but now even less than 5 years also, because previously we used to have this kind of a 5-year plan project, but now even the 5 years is a, we think that 5 years is a longer, long period. So that's why 3 to 5 years, maybe I would say. Alternate way monitoring sections of varying periods of service life, not possible for FDR. So an alternative to this 3 years or 5 years can be just 1 year, but in that we would judiciously select different sections which have completed varying service life. Let us say we have one test section which has completed 3 years, 5 years, 7 years, 9 years, and we monitor them for 1 year. We would be having the data. But of course, the key is that the soil conditions should be similar, weather conditions should be similar, traffic should be similar. But we have something we get in life, something we have to compromise. So that's why judiciously, if we select different sections which have completed varying periods of service life, that can also help. But I have put that here in gray color. That is because in the FDR, we don't have that facility. It's all new roads only. So that's why we have to go with at least 3 to 5 years of monitoring. Performance monitoring once before monsoon and once immediately after monsoon season, that I have told you. Identify correctly the onset and withdrawal of monsoon, especially with everywhere this onset and withdrawal date, they vary, monsoon, and every year also it varies. So all these factors, they should be kept in mind. Next one. Visual condition survey, qualitatively and quantitatively assess the distress seen on the road. Of course, the visual condition survey, we can do it using a mechanized manner in using the network survey vehicle. But for rural roads, which are having a length of hardly some 3 to 5 kilometer or maybe 7 kilometer, so this using the network survey vehicle, not something required. So we can go ahead, the best option would be the manual visual condition survey. Network survey vehicles, definitely they use it for this highway works, and that's required in highway works also. Surface defects, bituminous surfaces, of course, it may be fatty, it may be smooth, it may be it may be having streaks, or it will be hungry. So depending on that, the different types of distresses will develop: cracking, deformation, and disintegration. Cracking types, deformation types, disintegration types I have written there. These are all, of course, you know that. Next one. Pavement condition index, depending upon whatever the visual condition survey that we have carried out, we can rate the pavement using the PCI. This is also a very time-tested procedure. And normally, in our IRC codes, we have just a good, fair, or poor. So that has to be expanded to accommodate the PCI values. Edge break, what is the length, rating, depth, the manner in which we rate the pavement depending upon the type of distress, I have written it there. Potholes, patching, rating, etc. Next one. This is the rating, suggested rating rating chart for the flexible the FDR pavement. So this, of course, referring to the IRC code as well as referring to this international literature also. This is has been suggested. This is taken from the draft which has been given to the NRIDA, and definitely it can be. It's only a suggestion, the draft. A little bit of changes can be made. The recording format for this bitumen pavement distress. Next one. Okay. Pavement condition index, some more important points. It's a simple and convenient and subjective way of rating the pavement serviceability on a scale of 1 to 5. What is 1, what is 5 written there? Based on the overall degree of failure, rating is assigned from the visual condition survey. PCI can be decided. The operations manual of PMGS5, it gives 2 more methodology also for rating the pavement, PCI rating. One is on what to what speed the vehicle can be driven on that particular road, and how much comfortable we feel on that particular road when we are driving at different speeds. If we cannot drive more than 10 km/h, it is the very poor. if we can drive over 40 kmph, the normal design speed, so like that and all. So we can go for, we can say that it's good to very good. Next one. Structural strength evaluation, applying the standard load to the pavement, measuring its response in terms of deflection or stress or strain. So this, for structural strength evaluation of these FWD roads, we must use falling weight deflectometer, as Dr. Vishnu has told yesterday. That's the best equipment. Of course, the equipments like Binkelman beam and LWD are also there, but the Binkelman beam, of course, it represents static loading, whereas whatever the loads that come on the any road pavement, it's a dynamic. So only the FWD, which is an impulse loading equipment, it correctly represents that loading pattern on a road. Next one. Deflection measurement is the easiest. Stress or strain measurement will be, of course, it will be very tough, at least for the highway engineers. Structural engineers, they are lucky. They can measure the strain easily. But for us, it's difficult. So we go ahead with the deflection. Strain measurement is easier in the structures rather than the road pavement. So that's why. And the deflection test is done in the wheel paths of the bituminous pavement. The spacing depends on the whatever the IRC code 115 is there, that we do that. Layer moduli calculation from the deflection values, and we can determine the residual life and overlay thickness if required using this FWD results. Next one. Functional performance evaluation. There are many equipments which are available, starting with NSV. Many equipments which are available for functional performance. Pump integrator used to be the preferred equipment previously. Now NSV is the equipment for highways, but these are not required. For our rural roads, we can go ahead with Merlin. Merlin is a very cost-effective, simple equipment, and of course, the one photograph I have, one drawing I have given there. So it is having the probe, and it is kept at 200 measurements. That means it is kept at 200 locations in our test section. And depending upon that movement of the probe, that pointer is there, the pointer will move. Next one. The pointer and the graph you can see there. So it will depending on that, we get a graph of that this roughness of that road, and we can calculate IRI, International Roughness Index. So that is expressed in meter kilometer, and how much of IRI represents the type of surface I have given there. Next one. Next important aspect will be the test pit study. We'll have to, of course, test pit study is required at the DPR stage also. Test pit study will be required when we are going ahead with the monitoring also. Test pit study is required for the physical verification of the layer composition, density, thickness, etc. Once or twice it is to be done. 3 test pits per kilometer, and size of the test pit, etc. I have given there. We have to collect at least about 450 to 500 kgs of sample from the test pit for laboratory evaluation. Next one. Different tests that are to be done. Of course, these tests, if our control section is a granular pavement, where we will be doing this test. If it is a FDR layer, then definitely, of course, the entire pavement, the base and subbase will be the single layer. There, of course, there is no gradation or anything, LLPI test, etc. For that, we have to go ahead with core cutting. Next one. So some photographs of the test pit observation. Of course, that's for granular pavement, and they are doing it. Photos are from Odisha, I believe. Next one. These are the photographs which represents when we are doing the DPR preparation. For FDR layer, previously, the core. For FDR layer, we have to extract the cores and we have to test the cores. So about 100 mm dia cores are to be extracted and tested for the compressive strength, and that is to be converted into cube strength after applying the corrections. Of course, if the dia to height ratio is 1:2, no correction is required. If the dia to height ratio is less than 2 or more than 2, of course, cannot be more, it may be, I don't know, depending on thickness. So we will have to apply the correction, and this correction to be applied, NRID has already given the methodology for applying the correction for the cement concrete roads. We are using that since many years, and same manner, same equations, I believe, can be applied to FDR also. So there is no change is required, and the cube strength calculation also I have written there. Next one. Traffic survey, we have to correctly estimate the vehicular traffic, and it's to be done once or twice this thing during the study period. And survey is to be done during the harvesting season, because harvesting season represents the maximum traffic that will be plying on that road to continuously for 3 days. And manual traffic classified survey along with the axle load survey is to be combined, and ATCC survey when traffic exceeds 1 MSA. This is as per the NRIDA specification. So even if we are preparing this DPR, we have to go ahead with this ATCC survey if the traffic exceeds 1 MSA. Same in the performance monitoring also, we have to go for automatic traffic counter classifier technology. Many ATCC technologies are available. A pneumatic tube and all, it has to be used with judiciously, because next one. ATCC survey has to be used judiciously, because even nowadays also most of the animal drawn carts are of course pneumatic wheel, but few states like this Maharashtra and Madhya Pradesh, they still have steel wheeled bullock carts. And then another important point is that even where there are tractors are there, they use cage wheels, because they want, they want to work in the rice fields, they must be fitting the cage wheels for the tractors. So these cage wheels, of course, they don't fix it and remove it like that. So it will be there even when it is moving on the bituminous road. So these cage wheels, they do a lot of harm for our bituminous roads in the rural areas. Unfortunately, we have to educate them. Anyway, that's a different issue. But these cage wheels will be harmful even for our ATCC equipment also, if it is a pneumatic tube. So the best way would be the video-based survey. That would be the best ATCC equipment. But with the video, and of course with the pneumatic tube classifying this two-wheeler and cycles may be problem. Not with this video-based, I believe. The software should be able to detect properly. Efficiency of counting, the percentages I have written there, and that is to be checked manually by 3-hour manual survey. Okay, next one. Axle load survey, we should use portable V-wave weigh pads, and that also should be done during the harvesting season. Sample size should be 85 to 100%. This is one departure from the highway works I have written there. In highway, normally we do about 15%, 20%, maximum 25%, because the heavy vehicular traffic is very significant there in the highways. We cannot, we need not weigh each and every truck. We weigh 1 in 5 trucks or 1 in 6 trucks, like that. So, but in rural roads, the traffic itself is lower. Traffic of this heavy vehicles is even more lower. So that's why in rural roads, we must go for at least 85 to 100%. Axle load to be, data to be collected, and axle configuration wise, we have to weigh that. Commercial vehicles, including the buses, are both loaded and empty, are to be weighed. Next one. Weather data, daily record of rainfall, temperature variations, and snowfall, if applicable, of not for Kerala. Recording the extreme weather events, like I told you regarding this cyclone. So if because of that extremely heavy precipitation, the road fails, if we have the climate data, we can back up our claim that the failure is because of these reasons, like that. Data collection station should be as close to the test road as possible. From IMD or private agencies in hilly areas, setting up of automatic weather recording station can be explored. Next one. Drainage and shoulder condition survey. Adequate drainage is required. Of course, you all heard about that. You know about that. for maintaining the structural soundness as well as functional competence. Camber to be checked, side drains to be free from debris, etc. And shoulders should be compacted, no edge drop. Sorry, of course, this edge drop is a phenomena which we encounter in highways as well as in rural roads and all over India. You travel to any state, everywhere this problem is there. Even in city roads also this problem is there. It's a nightmare for driving, nightmare for drivers. Unfortunately, this condition continues. So just like our potholes, I don't know, this edge dropping is not, it does not get so much of attention from the press compared to potholes anyway, but that is also a very important issue. Drainage to be rated 1 to 5 scale, depending upon how better or how worse it is. These are all required for developing the modeling. So now coming to modeling, what is modeling? Modeling is a mathematical description of the expected values of a pavement attribute will take during the analysis period. The attribute means maybe functional performance, IRI values, or it may be deflection values, structural attributes like that. And the way in which the pavement's serviceability condition change with the time, of course, that is called the performance, pavement performance. And the way in which we model these changes is the what is a mathematical equations we develop. That is the performance modeling. Previous. FDR technology pavements may outlive the conventional pavement or may fail prematurely. I don't know. It is only I have written. It may definitely, let us hope that it will outlive the conventional pavement, and in some cases, maybe any reason, I don't know, it may fail prematurely also. So long-term performance study needed, but because of the reasons I have already told, economy and quicker conclusion, we go for this limited period, and we whatever the data that we have, we enhance it by modeling. Next one. Next one. So this is the way, of course, the performance comes down. With time, the performance keeps on coming down, and these are all standard diagrams. And once we go ahead with the maintenance alternative, maybe 25 MMBC, 40 MMBC, 50 MMBC, like that, what will be the ultimate, what will be the resulting serviceability that can be predicted using such modeling. Next one. Different this payment modeling, it can be at network level, it can be at project level. Of course, PCI and IRI, they play a significant role in the payment performance monitoring. Monitoring and evaluation data, structural and functional performance data, environmental conditions, material properties, and traffic loading. This is what is required, and various combination of these different data that we use to develop our models. Out of about 100% of the data that we have collected for this 3 years or 5 years, 70% we use it for the development of this data and development of this model, and around 15% each we use it for testing the data and validation of the model. Testing the model and validation of the model. Accuracy of the prediction, it depends on how we correctly identify the factors which affect the payment degradation and what accuracy we have achieved while collecting the data for these factors, for these variables. Next one. There are many types of modeling we usually adopt. One can, of course, the broad classification I have given there. It can be, the models can be deterioration models, or models can be life expectancy models. Deterioration models are the more predominant in literature, and of course these two can be classified as deterministic, probabilistic, and machine learning. Whatever the data is there, if we predict the performance using an empirical manner, that constitutes empirical models. Like example, the deflection is there, that depends on the traffic. So we take the traffic, consider the traffic over different years, and we consider the whatever the deflection is there, and we connect this traffic with the deflection data. That's empirical, but that's because I am not considering any material properties while developing my model. I'm considering only the traffic. So in an indirect manner, we predict the structural performance using the traffic data. So, but if we consider the material properties also, that constitutes mechanistic modeling. But of course, determining the material properties will be difficult. Our payment is support the manner in which a structure is building is built and our payment is constructed. They are different. So that's why more than mechanistic, we rely upon mechanistic empirical methods. So we partially consider empirical factors also, we consider this mechanistic factors also, and we develop. So that is the more appropriate, more used type of modeling. Probabilistic, of course, that's also another important area. Professor Isaacs is expert in that. And the machine learning, of course, nowadays we leverage the artificial intelligence of the computers and develop these models. Many varieties are there of the machine learning models. Artificial neural network, that's more popular. The same manner it applies to life expectancy models also. Next one. So if we see the total models that are there in the literature, about 50% are deterministic. The probabilistic and 50% is empirical, and the probabilistic and the machine learning 25% are each. The empirical models, as I told, it uses the contributing factors and develop regression equations. Traffic is an important factor for highway payments, not for rural roads. Consider only CVPD. So this is another important issue. Whatever I have seen from the literature, that even though in the highway sector, they use traffic as a major contributing factor for the deterioration, in the rural roads, the traffic is very limited. So that's why many of the researchers have come with the conclusion that we need not have to consider that. And some of the researchers, they have considered only the commercial vehicles per day. So that would be a better, because the bulk of the traffic in the rural roads is two-wheeler and bicycles like that. So these, of course, not going to contribute much for the deterioration. Considering only CVPD, the equations have been developed. That would be a better manner. Machine learning, it explores inter and intra correlations and patterns in between the variables, and this thing, it is having least human intervention. So that's why it's always considered to be a kind of better way of this thing. Maybe it's the futuristic type of modeling. Next. Next. Once we are through with the modeling, we can go ahead with this life cycle cost analysis, economic evaluation for judging the long-term performance of different payment options, investment options, assessing the total worth of infrastructure, considering the initial cost and the discounted future cost. That's the life cycle analysis. There are many methods for this life cycle economic analysis: net present value, cost benefit ratio, IRR, internal rate of return, IRR, etc. For this FDR roads, for these new materials, this net present value, that's the best method. That's the best method, I can say, because the cost benefit ratio, what is the benefit, what is the cost going into that, that may not be suitable in case of this new materials. Will not be able to predict its performance very correctly. So that's why I believe this NPV, net present value, that would be the best method for this arriving at life cycle cost analysis for this FDR as well as new technologies. Next one. The steps involved: design and construction data is to be collected. Okay. Then, of course, this can be collected from the estimates. and the project cost. Then we have to correctly choose the discount rate and the analysis period. Analysis period, PMGSY roads normally 10 years. That would be the optimum analysis period. And discount rate. This is very important. Actually, the discount rate, we can take it as the lending rate, lending or borrowing rate by the government around maybe 8, 9%, 10%, like that. But of course, in developed countries, if you see the literature in developed countries, they take the discount rate as 3%, 4%. That will not be applicable to developing countries like India. 9%, 10%, that would be the optimum value. Determine the expected performance, decide the strategies for maintenance or rehabilitation and their timings. This we are going to do from our models that we have developed. That's the contribution from the models. And once we are we have done that, we can estimate the various costs, initial construction cost, of course, that is known from the project estimates, and construction records, maintenance and rehabilitation data, and user cost. User cost, of course, we can take it equal for this new technology road as well as conventional road, considering that they are both going to behave in the same manner as far as the user is concerned. And NPV, net present value, is to be computed for both the test section and control sections, and a report is to be prepared. Next one. Some details regarding net present value calculation. This is, of course, you people would have read it in your graduation and post-graduation. Analysis period, to take it as about 10 years. Discount rate, I have written 10 to 12%. 12% nowadays, it may be a little bit higher. Anyway, whatever the market rates are there, that we can take it around 10% would be 10, 11% would be, say, okay. A construction cost, of course, we get it from the estimate. Next one. Okay. NPV calculation, this is the equation, which of course you all know. Move on. Maintenance schedule for the PMGSY roads, to ensure that the roads remain serviceable throughout their service life. We do the maintenance. And the NRID has given the maintenance schedule and what is the expected cost for this bituminous roads using conventional materials. So this is what they have given. And of course, this may not be applicable for FDR roads also. This may not be applicable for FDR roads. So that's why the performance monitoring and modeling, they would be very much needed. Next one. Environmental and social costs. This is a very important issue now in present conditions, because we should be bothered about this climate change, CO2 emissions, etc. And this life cycle analysis, it deals with this assessing the environmental impact of the alternatives. FDR technology is considered to be a green technology. Definitely, it is a green technology. There will be a lower CO2 emissions also. So this, of course, it will lead to lesser carbon footprint. There are so many softwares are available for calculating the carbon footprint. Changer is one, and I believe this open source softwares are also there. Social cost of that CO2 emission for India, which has been calculated in the literature, which are reported in the literature I have given there. So based on that, we can come to we can compute this environment and social cost also. So in the life cycle cost analysis, this also needs to be added. That's the better manner. Next. The final steps, of course, is the report preparation. Once we are through with this monitoring for 3 to 5 years and our report preparation, analysis and report preparation. The report will contain the details of FDR technology, test and control sections, payment performance monitoring, analysis, what we have done for this modeling and etc., cost analysis, and conclusions and recommendations, including suggested specifications and a rate analysis outline. So these are the various components which will be there in our report. Thank you. And if you have any question, I would be glad to answer.
Thank you, sir. We can have three questions from the audience.
Good morning, sir. Sir, in your presentation, you are actually saying that we need to do a axle load survey, but later in the subsequent slides, you were telling that we could report this in terms of CVPD. So which one we have to adopt? Whether we have to report in terms of CVPD, because we are not trying to express in terms of equivalent standard axles.
Actually, when I talked about CVPD, it's what is there in literature. So while developing the models, the option is there. We can go for the CVPD, the easier option, because the researchers, they did not do any axle load survey. They went only for traffic survey. So that's why it was there. But if we do the axle load survey also and project it in a better manner, I believe our models will be even more effective.
Yes, sir. Yes, sir. Sir, one more doubt. So you were saying that we need to do a test pit investigation, but generally the roads after construction, we need to get a lot of permission to open up test pits. So why don't we rely it on the as-built, I mean, or the drawings? Because opening up test pits, people will not allow. That is an issue.
No, even to make any particular road as a test road, and that also needs permission. You cannot go to any road and start your analysis. You have to get approvals from the implementing agencies and implementing. This is a policy.
Yeah, I agree.
It's a policy. NRID has wants to go ahead with this performance monitoring. They have identified particular roads. So in those roads, of course, even when yes, this SQM monitoring is there, NQM monitoring is there, they do the test pit analysis.
Okay. Thank you, sir.
What?
Sure. Will do.
You have to, it has to be.
Yeah, will do.
And
Yeah.
top 10 centimeter, it has to be repaired by using cement concrete also. Those issues, of course, I have.
Sure. Thank you, sir. Yeah.
Dr. Gurul, see, the whole thing is that this is for low volume roads, or we intend to have it for high volume roads?
Yes, FDR technology, definitely we can use it for high volume roads also and low volume roads also. And if we go for this high volume roads, our methodology will have to be little bit modified. We cannot go for visual pavement condition survey, sir. We have to go for NSV, and of course FWD will be there.
Even this FWD can be avoided for low volume roads, no? Because you don't expect any structural failures in the low volume roads, because if there are no vehicles moving on the road, then naturally the impact will be only on a visual, I mean, the functional.
Agreed. I understand, sir. This the alternatives to FWD can be LWD, lightweight deflectograph. But LWD equipment, I have been seeing it since 1990s when it started as Loadman, and of course now it's very much improved from in hardware as well as software also. But still, the modulus value derived from this FWD is not as reliable as compared to FWD. And FWD, we can hire it for about 10,000 rupees per kilometer. That is the hiring charge. And so 3 years or 5 years, definitely this FWD study can be done. And that's what the NRID is now proposing to do, sir.
Sir, in an evaluation period, which is only about 1.8 years, you have to go for family of roads concept.
Yes.
Okay.
Yes.
Thank you, sir.
Yes. Having different service lives. But that is not possible in FDR.
5 years.
Okay.
5 years.
Okay.
They constructed that one.
Achha, good.
In 2018.
Achha,
18,
good.
No, that is an MDR.
Truck traffic. It's basically buses and
that's only 1 or 2 roads may be there.
Questions?
Hi, sir. So when you mention about the life cycle cost of the payment, is that we have to consider the road user cost and a vehicle operation cost also in that?
Agreed. Well, we have to consider those aspects also, but I am assuming it will be same for a FDR road as well as a conventional road, because the same type of paving surface is there. In the same road, we are constructing this test section as well as control section. So that's why I am assuming user cost to be same for both.
Thank you, sir.
So this is one for.
Thank you.
So some 32 centimeter, 33 centimeter may be the height, more than 30 definitely.
Thank you, sir.
This is which technology? Table. Okay. Oh, this is from Andhra. From Kerala.
Thank you, sir. Thank you for the presentation on evaluation and performance modeling, monitoring of FDR roads. Now we have the next session, lessons learned from FDR projects in UP by Dr. Shyam Nair. Dr. Shyam Nair is a faculty at IIT Kanpur. His area of research include physiochemical characterization of payment materials, use of recycled materials in payment applications, full reclamation of payment, construction management, project management and control, stabilization of surface layers. He's having more than 8 years industrial experience, both as practicing engineering and as consultants in private and public sector organization. We welcome you, sir, for the presentation.
ടോപ്പിക്കിന് ചെറിയൊരു മാറ്റം ഉണ്ടല്ലോ. Hello. Yeah, good morning, everybody. So, my name is Shyam Nair, and I'm a faculty at IIT Kanpur. So, I have been working in this area for quite some time now under various capacities. And of course, as a faculty nowadays, and along with that, I've been working as a practicing engineer also at some point earlier in my career. So first thing I want to say is about a minor correction. So originally I was supposed to talk about the experiences in UP. And I understood that Dubeji from UPRRDA, he has given the presentation completely about all the pluses and the things that UP has actually done. So in lieu of that, I'm going to be talking a little bit about various broad aspects in the scheme of full depth reclamation itself, which will be some introductory parts which you might all have seen many a times in the last, from yesterday onwards. So just bear with me on that. So I'll just start off my presentation with a brief introduction of things. Next one. So first of all, utility of FDR. Like what exactly are we trying to do here? When is something like an FDR going to be useful for us? Now we all know that our roads, especially the village roads, has been going through a lot of payment traffic over a period of time. And many of them are in a condition where they are actually at a stage where some kind of a structural upgrade has got to be done on these. So FDR is a potential technology that can be used in these particular cases. What are the ones that are going to be eligible? What are the ones that are not? I'll talk briefly as we go along. So typically roads, if they have gone through significant amount of aging, then the structural value of those roads, if it is not up to the par of vehicular traffic that we are having right now, And of course, as you know that the vehicular numbers have increased significantly over a period of time. So as a result of that, the level of service of these roads are actually much less than what it should be. So these are some of the cases where typically this FDR technology can be implemented. Now, coming up to about rehabilitation, how can we do that? There are two ways. One is a conventional approach and the other one is the new technology that we're talking about. Now, what is conventional approach? You all know that, right? So it is basically about, I will think of it as something that we are building up from what is there. Basically, I'm talking about a couple of options, starting off with simple overlays. What does an overlay do? It can actually increase or extend the service life of a payment by quite a few years. But there are some underlying issues that are there when we are going for a overlay option. Because if the pavement has undergone any kind of distresses, say for example, base or subgrade issues, putting an overlay on top of that is not going to help us very much. Say another example would be there's an extensive amount of fatigue damage on these pavement sections. If we cover it up with an overlay on top of it, you all know that possibly in the next 1 to 2 years, those cracks are going to emerge through, making the pavement again not usable. So those kind of options are really not very good in case of these particular aspects. Now, the next option would be a costly affair, which is remove and replace. We are going to come in and we are removing the existing structure completely and put a new structure on top of it. Well, it is well and good, but the problem there is cost. It is not going to be economical at all. And now it is a time where we are trying to conserve the resources that is being available to us. So definitely not a very good option in my opinion. Now, the second option would be building down. This is where the FDR technology actually comes in. Building down means we already have an existing infrastructure. Why waste it? We are going to maximize the utility of the existing sections and we are going to put a topping on top of the rehabilitated structure and give a required amount of service life to the pavement. This is what the essence of FDR technology is all about. Now, by now you already know the benefits of it. Resource conservation is one. The construction window, which is one of the most important factors that we deal with when we are doing reconstruction works. A facility has already been available to public. Now all of a sudden we come back and close it down. There is a big public outrage. They want to get done as early as possible. So FDR actually supports that kind of an option. Economic viability and structural improvements, I will talk about it in the following slides. Now, in terms of FDR, what exactly is a FDR as a technology? It's basically rehabilitation technique which involves recycling an existing pavement. And in this recycling process, we are actually using the existing crust, base layers that is already there, and in many cases, or in most cases, certain amount of subgrade materials that is present in the location itself. And FDR or the reclamation can be done in multiple ways. And we, in the current scenario, we are actually going to be talking about chemical stabilization, where the strength enhancement is being provided by addition of cement along with certain other kind of additives. So now, first question would be, what is really the need for stabilizing this section? Why is stabilization so important? Simple answer, if you look at the graph on the left, what you can see is that one is a stabilized section versus the other one is an unstabilized section. We are basically reclaiming the existing material and we are putting it there without any kind of additive in there. So what happens when there is a heavy loading in there? The load distribution is actually going to be very much concentrated. And as a result of that, the subgrade is going to slowly start accumulating deformations. End result, rutting. Rutting is a major problem that comes in those kind of cases. Now, on the one on the right side, if you look at it, same case with a untreated layer on the bottom with a HMI layer on top. What is the problem in there? Once loading happens, the bottom layer actually starts flexing and the HMI layer also flexes along with it. End result, there is going to be poor performance in terms of fatigue. So stabilization actually helps in accounting both the rutting damage as well as the fatigue damage in these sections. Added advantage, we all know that water is the most problematic thing when we are dealing with pavements. Now, water can come in from different ways. One from the top if there is a crack on the surface of the HMI layer, or it can also come in from the bottom through capillary actions. Now, the advantage of this stabilized material is that it fills out the voids that are present in the matrix itself by addition of stabilizers. I'll talk about it briefly. The end result is that the permeability of this layer actually goes decreasing with respect to time. So once permeability decreases, water movement from underneath is going to be stopped completely. So you are going to get a better life for your pavement section because of the reduction in the permeability of these sections. Added advantages when compared to overlays and other options like milling and filling. Crack propagation is one problem that we all encountered, just like what I have mentioned earlier. You have a fatigue problem on your pavement surface, you cover it up with an overlay, less than a year, the crack starts showing up again. The same is going to be applicable in case of a mill and fill option as well, unless you do some kind of a corrective option. Reason is that the continuity is still maintained. The cracks eventually cuts through, and milling option also gives you has a problem with reflection cracking in there. Now, in case of FDR, what we are trying to do is to completely recycle the material. So there is not going to be any existing bitumen layer as such after this process, which means that the reflection cracking problem is completely sorted out. It will not happen, or to a very good extent, it will not occur at all in these sections. Some other added advantages, it can be useful in terms of adjusting the cambers, longitudinal profiling of the road. These all can be accounted for by various options. Of course, in certain cases, you may have to include additional new fresh material so that the profile corrections can all be done. And again, that is not going to be covered too much as a part of this presentation. A simple comparison in terms of cost. This is one of the typical examples that one of the initial projects that was done in UP using emulsion as an additive. So as you can see, the cost variation that you see in the second part of the graph, approximately 30% reduction in cost because of this particular technology. Basic difference is that the amount of new material that is being brought in is going to be much less. Now, along with new material, what comes in is the transportation cost, a major chunk in construction nowadays. So that is taken care of as a part of this process. So that is why the cost saving typically comes in. Now, how do we go for it? First thing is that FDR is a technology that people really start, nowadays I could see that people start taking it as something that is very simple. Please remember, it is really not like that. You are working with a set of materials, a mixture of materials, starting off with wrap, a base material which is of varying sizes, say from about 37 centimeters or plus to something like 19, 20 or even less than that. Milled fraction of wrap, which is less than 20 of course. You're going to have soil which is about 4 centimeters, 4.75 centimeter below. It's a mixture of all these things. You are adding an additive which is a chemically reactive additive, which is cement of course. Along with that, you are adding certain amount of additional mixing agents as well. So it's a combination of way too many things, and controlling, or rather avoiding variability that is happening in these mixtures is a very difficult problem. Now, how effectively this can be done is by proper monitoring, proper testing, proper mix designs, and all sorts of things, which we will talk about as we go along. So this is one figure you have seen, so I'm just going to skip that. Probably you might have seen this as well. On the left side, you have an existing pavement section. You're going to pulverize the section starting from asphalt, then the granular base, and part of a subgrade is also pulverized. Then the corrections in terms of levels. Let us say you are expanding a 3.75 meter road into a 5.5 meter, then the finished road level is actually going to decrease in those cases. Or in certain cases, if you want to purposefully decrease it, then that also is a possible option. So once you have this mixing process done, then you're going to add certain amount of stabilizers and put a small amount of overlay on top, which typically is of the order of 3.5 to 5 centimeters maximum. So types of stabilization, one is mechanical. There is an option for using emulsions and also additives, chemicals. Mechanical stabilization, I'm not going to go too deep into that. It is basically compaction. You are pulverizing the whole matrix, you're going to compact it by physical force, and that is what your FDR level is, FDR layer is. And on top of that, you're going to put your new surface on it. Now, applicability wise, it is much less when compared to others, simply because it is going to be effective only for low volume traffic applications only. Now, in certain cases, when you have damages in the subgrade or subbase layers, this option many a times is not going to be effective as well. So the moment you add some kind of a chemical additive, which is a cement or a lime onto it, that is what is, then is when it becomes a stabilized section. Couple of options, if you look at it, if you use emulsion, there are two options that you can when you are having an emulsion section. One is emulsion, the other one would be formed asphalt. Basically the same thing. Emulsion has minor issues when compared to other. More amount of fines, emulsions become less effective. The other one would be that the compatibility of emulsion with the aggregates that is present in the mix, that is also a key aspect which defines the suitability. So that needs to be accounted for also. In case of formed asphalt, on the other hand, the excess fines that are present can be taken care of easily. So that is the primary difference in between the two. Again, this technique can be applicable in terms of medium to high volume traffic, but mainly with surfaces which has got minor base damages or aging or oxidation related issues. Now, the main thing for our discussion would be the chemical stabilization, which comprises of two additives. One is lime and the other one is cement. Now, which one should we go for? Lime is effective in cases where the PI value, the plasticity index value of the soil is actually greater than 10, which means that there is going to be a significant amount of clay that is present in those soils. Now, if the PI value is less than 10, cement many times becomes the preferred option. Reasons we will talk about. And these kind of sections, the cement stabilized sections, can be used in high volume traffics. It can be used in cases where the pavement actually has base or sub-base damage. Then, all those sections, this can be used. Now, broadly, in terms of selection of a stabilizer, how can we do that? If you look at the left side of this graph, you can see that there are a list of additives that is mentioned there, which would be emulsion, then you have formed asphalt, cement, lime. So if you look at the graph on the right side, you can see that emulsion is, or bituminous stabilizers are effective mostly in case of granular materials where the PI value is significantly less. Now, lime on the other hand, the very last one, the yellow colored one, if you look at it, is more effective when the PI values is significantly high. I'm talking about 10, 15 plus. Now, cement actually gives a much broader range over which we can work with it. That is from around low plasticity to something like a medium plasticity. A PI of around 10 to 15 should be reasonably fine in case of cement. Now, any other reasons for preferring cement? Simplest thing would be that a construction time window. Cement gives good initial strength, early strength, which means that it can be open to traffic, not within weeks, within hours. Provided you have enough strength to sustain the traffic in there. When I say hours, 12 to 24 hours, you have to check if the minimum strength requirement is there for the section, and this traffic is not heavy vehicle traffic. This is lighter motor vehicle traffic can be opened up at these sections. That's a big advantage when we are working with an existing roadway section. Then another advantage is that cement can give you long-term strength. Reasons and how it is done I will talk about in the following slides. Broadly speaking, two types of soils. One is clay, one is sandy soils. Cement is applicable in both, but the mechanisms in which strength is given varies in terms of these two types of soils. If you look at clays with minor amounts, I would say, the workability or the water absorption capacity of the clays changes immediately. Cement hydration is there in both. It can give strength in case of clay soils as well as in case of sandy soils. And now you are talking about pozzolanic strength gain, which I will discuss briefly later. It is applicable in case of clays only. So this is just a pictorial representation, just trying to give you a feel of what exactly is happening in there. So what I have in there on the top is the basic cement chemistry equation. Every one of us has gone through it in our undergraduate. Cement reacts with water, forming cementing materials, calcium aluminate silicates and calcium silicate hydrates. Same cement chemistry hydration reactions. Along with that, what is also forming is certain amount of lime. So now if you look at the bottom figure, we have multiple things over there. The yellow colored platelets that are clay particles. You have aggregates along with it. So that is basically our pulverized mixture, which has got aggregates, clays, and certain amount of wrap as well. So now when cement goes in there, and with a certain amount of water, which is going to be the optimum moisture content, cement starts hydrating from the surface going inwards. So what happens is that when the surface gets hydrated, it actually connects or starts connecting these particles together, which means a matrix actually starts forming. That is where the initial strength of the cement mix is going to come from. So once the matrix is formed, it can actually take up some amount of load and it is good to go at the initial level for light or minor traffic. So now what happens next? Once the matrix is actually formed, cement, as you know, keeps on hydrating and lime keeps on forming. So the next set of reactions actually kicks in this particular case, which is known as pozzolanic reaction. Again, the same as that of cement hydration. Only difference here is that the pozzolon, which is the cementing, the part of the clay that provides the cementing agents, is much less here, and they starts dissolving very slowly. It's a slow process. So what happens is that silica and alumina in clays dissolve in lime, in presence of lime, and form cementing agents, that is calcium silicate hydrate and calcium aluminate hydrate. The same thing that was forming earlier, difference being the quantities in this case is going to be much low. Now, what is the advantage of having this? If you look at the same figure again, and if you look at the red circle there, earlier there used to be a void in that space. So now once lime and clay starts working, these voids actually starts getting filled up with these cementing products. Very slow process, but as the voids get filled up, we know what happens when the voids inside a matrix gets filled up with something, right? The strength keeps on increasing. The strength, the long-term strength of these mixes keeps on increasing over a period of time. So advantage, this is a slow process. The advantage in having a slow process is that many type of cracking, say for example, shrinkage cracks, which is a common thing in case of cement addition or cement treated materials, is not going to be there because the process is very slow. Now in between, there is going to be some amount of traffic, which actually starts cracking the surface a little bit. These cementing products actually keeps on filling those voids as we go along. Advantage of that, the strength keeps on increasing. There is no deterioration of strength in this process. In terms of timeline, when we talk about, you all might have gone to the site, you might have realized that compaction has got to be done in 2 hours. Now, what is the reason for that? Cement hydration gets complete, cement starts hydrating within 2 hours, starts setting. So you have to compact your matrix within that time period. Cement hydration or a period of time occurs over a period of time, starts with a few days and it gets extended over years or months. Pozzolanic reaction, which is the clay lime interaction that happens for a even longer period of time, which is in terms of years. Now, from a construction perspective, if you look at it, you can divide the processes that needs to be done into 3 steps. One is pre-construction checks, construction, and then post-construction. So if you look at pre-construction, that includes primarily 2 things. One is project evaluation and the mix designs that you all actually do before the project actually initiates. Construction steps you might have already seen: pulverization, stabilization, compaction, curing, and all those things. And post-construction is primarily about quality checks. Now, project evaluation, the first step is for you to identify whether a given road is a candidate for FDR process. Now, how would you do that? That's the first thing. Broadly speaking, almost all flexible sections can be considered eligible as long as it is seriously damaged and it cannot be rehabilitated or improved by doing simple touch-ups or maintenance or practices. Now, if there is a problem that you see that there is an issue with the base and subgrade, that would be another potential candidate. Now, a quick way of estimating this thing is that, let's say you have a road and more than 20% of the road actually needs serious maintenance, which means that the patch-up works we are doing is not going to be effective at all. That kind of a road is a good candidate as well. Now, there are certain exceptions in these cases which you need to remember as a practitioner. The moment there is a problem with water, drainage, that section is not an ideal candidate anymore. Simple reason is for the fact that water comes in, interacts with this cemented materials, they start losing out these cementing particles from there, and as a result, the long-term strength will not occur. So whatever you get before the water exposure is what you are going to have for a longer period of time. So you need to make sure in such kind of roads, the drainage issues are addressed properly before you actually perform the FDR works. Some other cases, if an existing road already has some amount of, or has some geotextiles in there, geogrids in there, those kind of roads are also not going to be eligible. Simple reason is that when you are trying to reclaim the material, the geogrids actually can come in between, and the mixing that you're going to get is not going to be very accurate. So as a result, the mixing will be improper, and as a result of that, the reclamation process will not be working good. Some other things that you should check for is the presence of utilities that are there in the section. Depth of existing pavement. That is one thing that needs to be verified by using trial pits. Like I said, the presence of certain amount of soil is going to be very critical in this FDR process, because that is what actually gives the strength. Think of a section where you have about 25 to 30 centimeters of actual pavement itself, and no soil needs to be taken out, because your actual depth of thickness of your FDR is going to be somewhere of the order of 25 centimeters. So now, if you are trying to reclaim that surface, the material that you are going to get is only wrap or some amount of base materials. Fine particles are completely missing on those sections. So now the moment that happens, then the additional strength gain process that I have mentioned earlier, which all gets affected because of. So in those particular issues, what you have to do is you may have to cut down the top surface, remove the unwanted thicknesses that are already there, and then if you are really interested, go back and then perform an FDR, so that some amount of base and certain amount of subgrade also comes into this picture. Subgrades which has got high PIs. If the plasticity index of the soil is high, it will have mixing problems, because the clay itself is going to absorb the amount of water that you're going to add to it. So the mixing and hydration of cement gets compromised in those cases. And that is why we do not recommend using cement in soils which has got PI of 15 and above. So you need to be careful about that as well. Second thing is organics. Nobody checks this, but remember that if your mix design gets compromised significantly, if this is not done. If you have an organic soil that is present in your location and you try to add cement onto it, it is not going to give you strength at all. I can give you my example in the last one month back. 6% cement into a stabilized layer, I'm getting a strength value of around 0.75 MPS. 6% cement. You cannot even imagine thinking anything about that. So that is the effect of organics that can have in your mix when it is present in the location. First and foremost thing about the whole FDR process, the key aspect, mix design. Often ignored, many a times compromises are being made, and eventually you end up seeing failures right away. What is the challenge in the mix design? We are actually creating not a flexible, not a granular material or not a rigid material. It is a semi-rigid kind of a layer. So the strength that the mix should have should lie within a target window. And achieving that target window is the biggest challenge. Problem with that is dependent on many other things. What are the kind of aggregates? What is the amount of wrap? What are the percentages of clay that you are actually using? All these things actually interfere with the strength gain process. And the challenge for you is to arrive at the typical mix design, considering that there is cement, and along with that, you are adding certain amount of chemicals as well to enhance the strength gain. So all these things complicate the whole thing, and it becomes very critical for us to come by with a estimate of what exactly is the optimal cement content that needs to be used. Now, sampling. Easiest thing that can be ignored. Now, why is sampling so important? I think you might have an understanding of that by now. Think about a section where you are sampling in one location where the thickness of the HMA layer, because of some overlays, is going to be different from the remaining half of it. Now you are basing your mix design considering that the quantity of wrap that is in there is going to be, say, 10 centimeters. And there are sections where there are 15 centimeters and more. Now, the mix design you have developed where the target window is achieved is based on this 10% material content. The moment that changes, it is going to be not falling within the bracket windows that you are looking for. End result is a failure even when you are doing your trial mixes or trial patches or even construction for that matter. Mixed design is perfect. Some accredited school has done it. You have done everything correct. All the process followed, but end is failure. Now, how can we overcome this? Simplest thing that we should actually have is to ensure that or try to get whether you have any history of the pavement, the rehabilitation works that has been done on the pavement, so that we can understand that which are the sections that are going to be similar, which ones are different. And you can actually play around with multiple mixed designs for these sections, provided they are in a reasonably span over which it can be effectively done. Multiple trial pits, practicing engineers, contractors, everybody ignores the relevance of it. There is no harm in going and opening up 3 pits in 1 kilometer and just check if it is the same or not. You don't have to do mixed design. Ultimately, please understand that end of the day, it is not the contractor's responsibility. Each one of us who is actually working on this is going to be responsible for the end result. Nobody cares about how good you've done it unless it is working properly. So the more effort you put in finding the sample material that is representative of the entire section, better you would be in terms of achieving a good mixed design and a good construction at the end of the day. Typically, we go with a staggered sampling, one along the center, along the sides in a staggered fashion. Simple reason is that wheel paths, this is particularly applicable when you have a single lane roads, where center is going to be less traffic when compared to the sides. So the thicknesses and all those things are going to be different. So you try to average out those differences by going a staggered way of sampling. Points to remember, visual inspection is the key. I mean, whoever says against it, I can't agree to that. A practicing engineer going out to the field, looking at it, you can clearly understand which one is different. Simple reasons. Patches are present, cracks are present, things are different, the material appears to be different. All these things are visual clues where you can say that this is one area that you should actually think about. Trial pits may just make to ensure that, okay, fine, the samples that we are getting is representative. I would suggest that if you are looking to find representative gradation, go with multiple trial pits and select which one is there, which one is good for you. Approximate quantities around 150 to 200 kilograms may be required. See, the critical parameter for the success of FDR projects, what I would say is that you are getting a mixed design that is done by a reputed organization. Try to make sure that what you are getting in field is exactly the same or within acceptable limits as that of that mixed design that you have actually created. If that is done, a good part of the problem is actually taken care of there itself. Just a broad overview of what the mixed design process is. Again, too much to talk about at this point. If you concentrate on the top half of it, first thing is sampling, which I said multiple trial pits is required. Basic things that you are looking for is the gradations and trying to see if the subgrade is involved in the stabilization process or not. If it is there, then you have to check whether the compatibility and the amount of fines that are present, the plasticity values and all those things. If it is not, then you're just interested in the gradation only. Once it clears off both, then it is about the cement content. Typically, we work with 3 different cement contents, try to do the mixed design by doing the moisture density, optimum moisture content, dry density of all these 3 different mixes. Then it is all about the strength and durability. Strength estimated based on unconfined compressive strength of the sample. Flexural strength is estimated, and the last one is durability. Please remember that there have been many cases where the strength is achieved, durability it fails. Strength and durability is achieved, the flexural strength fails. We have encountered many cases, even in my lab, when it comes to testing, I have seen that. So all these things are important, and mixed design has got to make sure that all these 3 parameters have been effectively taken care of. Then once the target strength values are met in each of these 3 cases, you can actually recommend the cement content that is meeting all those things, and the final design recommendation can be made. Now, one thing that I have not included in this is the role of additives, chemical additives, which again, is a combination. It becomes a combination at that point. We already have a complex mixture, but please remember, many a times there were cases which I have heard from people that people try to adjust this proportioning. There is 5% of cement and 2% of that quantity is going to be the additive. People kind of play around with this number to better for economic benefits. Believe me, it's a combination. Increasing cement and decreasing additive, or increasing additive and decreasing cement. Unless you verify it, whether it is working or not, you are definitely going to end up having a problem with your final mix. Again, this you have seen many times, I'm just skipping through it. So compaction and curing, these two are critical parameters. One thing is maximum dry density, maximum strength. So you try to achieve 98% plus with your mixes. Compaction time always happens. People try to push the numbers a little bit. Okay, fine, I have gone up to 500 meters now. Let us just go for 100 meters more and come back and do the mixing later. The moment you start crossing over that 2-hour time window, the strength that you are going, because the cement actually starts setting at that point. So once it is setting, you are trying to compact it, you are actually breaking the bonds that are forming in there, which means that the strength that is intended to get goes down because of that. So never push that timeline. Try to always remain within that. Curing, again, multiple ways possible. Simple moist curing is something that is often done, and the strength window is typically from 4 to 7.5. Now, what kind of checks as a practicing engineer can you do in an FTR work? First thing is the site data. Reviewing the available information would be the first thing, what I would do. Example, the mix designs, the soil survey reports if it is available, local information that you can gather about what has happened in those sections. Visual inspection. Trust your eyes, see what you are seeing over there, make sure that it is not significant. Be there, verify it, and don't leave that section unless you are sure that, okay, this is not a problem and it's not going to affect my mix. Drainage issues, utilities. Make sure that it is not there. And a good way of doing this would be to walk the entire length of the section before you actually work. May that be 4 kilometers. 3 or 4 of you can actually share that responsibility and do that like that. It helps find localized areas very well. In case of equipments, what can you check simply? One is that the reclaimer, is it good? Is the teeth of the reclaimer working fine? They are polished or not? Is the steel cutting edge is good? Those kind of checks you can make. Then in terms of water addition, is the quantity is correct? Then in terms of cement spreading, very important thing, is it falling uniform? Is it spreading uniform? The numbers that you are seeing in the reclaimer, is it correct or not? That is one thing that you must, every engineer who is in field must get into the reclaimer. They must be inside the reclaimer and try to see what the settings are, what the values have been set in the machine, and check it outside whether the same thing is what you're getting in the field as well. Cement quantities, water content, all these things can be verified. In situ densities, the quantity, all these things can be verified by looking at the reclaimer, staying inside the reclaimer, and doing your physical test outside. Pulverization, construction checks would be to check the gradation of the pulverized material that you are getting, whether it is matching with the mix design that you have already done or not. That is one good check. Moisture content. In case of moisture content, please remember that you will be having an optimum moisture content in your laboratory data, and in situ moisture content would be there in the soil. So you have to adjust those differences accordingly and add the required amount of water on top of it. Now, when you are working on a hot condition versus something like a humid condition, please remember that 1 to 2% of drying may happen due to the sunlight. So that should also be accommodated as a part of your water additions. Cement application spread rate that needs to be checked out. Construction practices wise, a good way would be that you establish your own rolling patterns. The first 100 meters or so when you are, or first trial stretch that you are doing, you try to see what exactly is the kind of densities that you are achieving, correlated with the type of passes that you have made. And that way it can help you in terms of kind of like, rolling patterns that needs to be followed can be estimated in the very first day itself and makes our life much easier later on. Mixing and compaction has got to be ensured within 2 hours. Curing moisture's presence has to be verified as well. We have to physically verify and figure out whether there are any soft spots, which is targeted spots that are there, which need special attention as well. Now, next comes the post-construction, which is the quality checks. Now, please remember that it is not just one factor that contributes to the end result. It is going to be a function of uniformity of pulverization, cement content uniformity, moisture content quantities, compaction that you are achieving. Everything actually contributes to the end result. So you need to check all these factors individually while you are at the field. And then only a good product can be obtained. Pulverizations, simple gradation that you can do in the lab office or the lab site that is at the site, it can be done. Now, if there is any difference that you see from mixed designs, simple corrections in the site itself can take care of it. Let us say the pass speed of your reclaimer. Now, if it's going too fast, what is going to happen? The grading is going to be bigger. Particle size is going to be bigger when compared to what you have gotten initially. If it is much slower, it is going to get finer. Now, those kind of adjustments you can actually make in the field itself so that a better quality mix can be obtained. Cement spread, simplest thing is to use a 1x1 square canvas. Let the cement spreader run over it and recollect that back, weigh it out and figure out exactly whether the amount of cement that is needed is being added or not. Moisture content. Couple of ways you can do that. Easiest way would be microwave or direct heating method, which can be done in the field itself. But a quick check for that would be the squeeze test, you would say. You take the optimum moisture content mix that has been generated in the field, take it in your hand, just squeeze it down. And when you open it up, if it is holding good, you are somewhere in the vicinity. Now, if it is holding good and if you try to break it, it just breaks us different pieces, chunks. You are almost all at the exact same optimum moisture content that is required. Now, when you do it and you open it, everything falls apart and falls down. Then you are way below the optimum content that needs to be there. Now, if you just again do the same thing and release your hand, if your hand is wet, your palm is wet, that means that you have crossed the optimum moisture. So ideal one would be take it, squeeze it, it would stick together and it can break it into small kind of chunks. That would be the best field estimation of what exactly the moisture content is. Now, next comes in is the uniformity of mixing. This cannot be done before compaction. So during compaction or after compaction, what you end up doing is to come down, cut a core out of it. Once the core is cut and taken out, you can use one phenolphthalein, which is a reddish pink kind of a chemical. You can just pour it on the side of this cut that you have made. And what it effectively does is that the color uniformity across the depth tells you whether the mixing is going to be uniform or not. If there is the same all the way through, you have a good uniformly mixed material there. If it is different, mixing is inappropriate. You may need to make corrections. Nuclear density is a check can be done on nuclear gauges can be used to check the densities. And one thing you have to remember is that the cores that are cut from the field immediately after construction, it cannot be used for any kind of strength checks. It is not a good thing to do. Even if you cure it for 7 days and use that as a reference sample, it is not going to work, because when you are cutting it with a low strength material, there is bound to form cracks inside of it, and you will never ever get the exact same strength that you are expecting. So those cores are never going to be used for strength measurements. Quality controls, again, I think the topic has been discussed. These are various depending upon agencies, and this is coming out of that orange book that NRRDA has developed, exactly the same numbers. So it's going to be, you're going to be checking for pulverization, then gradation, of course, cement application rates, optimum moisture content, then field moisture content, strength, and all those parameters. Again, the frequency numbers that is given there may vary depending upon agencies. Last slide. Just remember one thing. It's a very fast process in terms of time. You are going to have a 1 year time window. Mix design takes 2.5 to 3 months, because you have to do OMC MDD, you have to do your mixing and compaction, 7-day strength, 28-day strength, and after that another 24 to 30 days for your durability test. So considering all these things, if everything got go by dot, I mean, one after the other, you're going to take 25 days plus for your mixed design process alone. Approvals and everything, under 2 to 3 weeks, 3 months is gone now. Now they are going to come in and do the trial pits, which is going to be another 3 more months. So 6 months out of 1 year is gone already. The trial pit is approved. Now you are ready to go for construction. Every place have a minimum 3 months of construction or a blockage time because of rainfall events. No construction can be done during that time. So out of the 12, you are just left with 3 months of work time, which is enough. A typical speed of construction that what we are seeing is that around about 10 kilometers in a month. That is the approximate number that we are seeing. So 10 kilometers a month, a 30-kilometer package would be done in about 3 months, fair and good. But the problem really is that each one of these equipments that is being used in the system is extremely costly. And the working cost for a contractor, if I'm not wrong, would be 1 to 1.5 lakhs per day, Dubeyji. 1.5 lakhs per day for a contractor. So if a machine is lying idle for 1 month, he's actually losing 30 lakhs for nothing happening in there. And if you are expecting a contractor to do 30 kilometers when payment is stuck, I mean, you can understand what he's going to say about it. There's going to be inflated arguments, there is going to be problems, people are not going to gel together, all these issues are actually going to come by. So in my kind of FDR train, the last part is my introduction, my addition, a money train, a money truck. As the work progresses, the money truck should also go along with it, which means that as you go on, the payment should go in properly, which again is not a simple task. There are multiple levels of filter that practicing engineers, the governmental regulations put in for you guys. Please make sure that you don't sit on information. If it is wrong, it's wrong, move forward. One project gets affected, I can assure you that 30 kilometers of that stretch that the contract has taken, everything will be affected. So make a decision quickly, best interest, move forward. One more thing I would say is that try to stay flexible in your approach. Try to be open. That is what UPRRDA has done very generously, I would say. All the technical contents have been taken care of, but they have given the flexibility to make adjustments. And what they have done is that they have created a technical panel where various stakeholders have been brought in, people from IITs, people from NITs, then CRRI, all these forms a consortium. And when there is a technical issue, it is immediately taken care of. Decision done, move forward. That's it. So that kind of an approach is going to be really important if you are working on this area. And the moment you start delaying your payments and everything, it's going to get to a standstill. Please remember that in your mind. So I think that is all what I have for my presentation.
Thank you, sir. Thank you for the presentation. We can have 1 or 2 questions from the audience.
Good morning, sir.
Good morning.
Sir, suppose during FDR, we are not able to complete the compaction within 2 or 2.5 hours. It takes 4 hours or 5 hours due to some unavoidable circumstances. Now, what we should do?
So you are doing wet mixing or dry mixing? Mixing of cement and water together and then pulverizing, right? Good luck. It is going to be difficult. Okay, the moment, it is not about anybody's fault. I mean, it happened once. Try to make sure that it does not get repeated. You will get the strength, but see, cement hydration, how much time? 30 minutes is the initial setting time. 6 hours is the final setting time. So, which means that your strength gain period of the cement is practically gone by the time you are compacting it. So the matrix is already formed, right? So when the matrix is formed and you try to compact it again, you are breaking it. So it kind of starts behaving more like a granular material at that point of time. So when you try to do your flexural strength or your durability test, the material is inevitably going to fail at that point. So it is always better to try to stick within that time. So what can you do at that? It's not an easy thing I can say at this point. Because already the mixing is done. You cannot remix the whole thing because that is going to be involving cement. then the additive that whatever it is, you are going to add too much of that, strength is going to go above that 7.5 number. So you'll have absolutely no control on what is happening at that point. So that would be my answer.
Ultimately, what should be done?
Huh?
Well, ultimately, what should be done with that section?
Ultimately, what should be done to fix it?
No, to that section.
Uh-huh.
Should we?
See, you have to start. I mean, if you are pretty sure that this is what has happened, and I am fairly sure that you might end up having problems later on, you may have to think about, reworking the whole section as such. I mean, I would say. If it is 6 hours, I would say it is too much. I mean, you will not be, correct me wrong, Dubey, if you're, so if it is more than 6 hours, there is very less chance that your section will pass and you will have to start through the entire process, which you have done earlier. Leave that section off, move forward, get your work done. Try to do recheck on the mix design at that point, which will change. That 500 meters will change. Come back and do it. Make sure that the durability standards are met at that time, and then you move on. So that section will lie like that for some period of time till the mix design is done. Otherwise, you can take a risk as well. Now, keeping in mind that, okay, fine, there is a chance in here for failure.
Okay, sir, one more question. Suppose we are doing a little bit profile correction. The question I am again repeating. This question was raised yesterday also. Okay, thank you.
Yes, sir.
I just wanted to ask a small question. I mean, now that you have constructed a full depth reclamation and done bituminous concrete over it, assume that it fails.
That fails.
Fails maybe after 5 years, 10 years.
Uh-huh.
Can we redo the whole thing again? Or what do you suggest? Are you going in for an overlay?
See, the mode of failure is going to be cracking, right? Cracking is going to be the primary mode.
I mean, I'm not talking about the failure type. What will be the next course of action?
Yes, I'm saying
rutting. Will it be an overlay or will it be again a full depth reclamation?
See, going for a second reclamation is going to be, first of all, expensive. Second is going to be whether you are using a SAMI layer in between or not, because it's a geogrid material. So if you have a SAMI layer, doing a FDR again on it is going to be a problem. So what I would think of is that if it is not a very significant breakage that you are seeing, put another additional layer on top of SAMI, which is going to cut off that crack propagation, and put an overlay on top.
So you expect, you expect a crack to happen because
crack to
happen in this layer?
No, if it is typically held within the window of strength, that has been mentioned there, chances of cracking is very less.
So in that case, can we, assume that you want to have a new pavement? Whole thing, everything is new.
Okay.
So you apply a soil stabilization of the down.
Second time.
First time.
Okay.
First time, it's a new pavement.
Okay.
So, this concept of here doesn't come there. How do you view that?
Right.
It's only stabilization. And then going in for a layer.
Right.
What is that use?
So you're saying that whatever...
I have a new payment, nothing.
Okay, you have a new payment, okay.
How would you do it?
Do what? FDR?
Stabilization, no? Is it a stabilization?
You can go with the IRC practice of stabilization. The reclamation is because the RAP is coming in and additional materials are coming in, the subgrade is coming in. If you're going with the regular construction, you can go with the CTB specifications, CTB cement treated base stabilization that IRC has got. Simple solution.
Yeah. But then you will apply ARC 37 for the design, or?
Yes, of course. That design will come in accordingly to that, yes. Here also we use that IRC 37 when the traffic is about 2 MSA. Below 2 MSA, that is one SP72, right? That is being used for your design purpose. So if you, in your particular case, if you are using fresh materials, you want to do a stabilization, there is standard practice that is there in IRC specifications. Just follow that one.
Thank you.
Sir, I think the recyclability of sections incorporating SAMI, the second recycling after FDR would be difficult, but the one with the CRL, aggregate CRL would be pretty easy.
If you have a crack reef layer as an aggregate layer. It actually is a policy decision at that point, whether you're using a SAMI or some other layer in between. UP has preferred to go with this one, a SAMI layer.
SAMI. That is because they don't get fresh aggregates. Their lead distance is quite large.
Reasons and reasonings, I don't want to go into that.
I think Dubeji would agree with that.
No,
yeah.
It was one of the reasons, possibly, maybe he can correct, but SAMI is a thickness wise, it is much less. Then it is already a bonded layer at that point. Because you are actually fixing it onto the existing layer. So no issues related to any kind of uneven movement or anything, because it is directly sitting, 6 mm layer sitting on top of your CTB. So no issues related to that in terms of compaction issues or anything like that. That was one other reason. Then if you have a granular layer in between, you are again putting a 2 centimeter thick or a 2.5 to 3 centimeter thick overlay on top. So that cushioning effect can be a problem later on as well.
But the recyclability of that section is
yes, of course, it is much there. It is very much there.
Sir, is it possible to lay BM layer directly over a FDR?
BM
application of
BM
layer or bituminous layer.
BM, right? BM. Oh.
BM layer.
See, the purpose of BC is provide a wearing course. Driving surface, smooth driving surface. That is simply the role of this BC in this particular section is. That is why we are going with something like 3 centimeters only. No structural value to that, right? So once you have that, you are not going to increase it very much because of other fatigue related issues that can come in because of dual axles and all those things. It is a minimum thickness that you are providing on the surface so that uniformity is obtained. Now you have a BM that you are using, the aggregate size is going to be higher. You are looking at about 19 millimeters. Now, which again leaves me the problem that moisture can be a problem that can get into that. Again, like I said earlier, the layer is not going to get affected, but there is always an interface where a BM is there and a CTB layer or a FTR layer is there underneath that. That interlayer can create issues at that point if the water is not properly blocked from entering in. BC takes care of it, DBM not so much, or a BM not so much. So I would rather try to stick more with the BC for the surfacing part. Again, to add on to that, chipping carpets were also used in many cases earlier, but now I think the recommendation from PMGSY is go with BC in all cases.
Any possibility of the reflection cracks, sir?
Mostly not. Only thing that can come in is shrinkage. Shrinkage, when the cement actually sets, it actually shrinks, right? So cement shrinks when it sets. So if that crack is there, then there is a possibility that it can cut through the bituminous layer. That is why we do not want to raise the strength beyond 7 MPas or so that the shrinkage cracks are minimized. That way cracks not at all appear in your mixture in your case.
Sir, I would like to know the majority of the FDR session, the designs, mixed designs, everything is going with the cement stabilization. Given an option with the bituminous stabilization, what will be the reason that we are more focused into cement alone?
That is, I mean, see the applicability is
UP, mostly it is going with the cement stabilization. So like
leaving all other administrative decisions out of it, or rather other aspects out of it. See, it's about applicability. Now, you have a material which, let us say, UP has been going through with around 6,000 kilometers already. You might have seen the presentation yesterday. Think about the diversity. Now, you don't want to end up being in a situation where this area you go with emulsion, this area you go with something else. It creates a lot of confusion. And the technology and the process itself has got to be refined in every single case. The way in which emulsion is mixed, the kind of machines that are required, everything changes in that case. So now, if a contractor who is working in one location, think of it from his perspective, he wants to get a work here. And after some time, he wants to follow up in a work in a different location where the entire process is actually changing. Then it may not be a feasible option for him at all. That is one side of the story. So considering that applicability on a wider range, cement is the chosen one. Emulsions works only in case of granular materials. In case of UP, if I can say, silt, clay are the main things that you encounter in UP. So when you are dealing with emulsions in those cases, the mixing and coating that you get in these mixes is going to be very poor, because emulsion still directly absorbs something, and the more it gets absorbed into that, the mixability becomes a problem. So uniform mixing is very hard to achieve when you have these kind of mixes. Another reason for selecting cement as an alternative.
So when we are like about to implement this aspects in Kerala, maybe we may have to look into the feasibility of different.
You can always do that. I mean, it is not like cement is the end of the world kind of thing, right? I mean, always good to explore new options, try to see if this one works better. Of course, UP has done so much good work on it. Well, let us come with a new model where we are trying to do something else along with cement. Applicability wise, it will be much more. But Kerala, if you look at it, most of these as red earth, right? Red earth, Moram kind of red earth is what we are having here. So it should not be much of a problem, I would say. These are non-plastic materials anyways. And there should be a good amount of fine size aggregates also that you get in these soils because of the breaking process and everything. So can work. I mean, I think maybe Sandeep sir, if he's around he is not here. He may be a better person because he has worked in different areas with emulsion-based additives. So he may be a better person than me to address that. But technically, these can be the problems that you may encounter.
But maybe the flexural strength possibility, you were mentioning that we get strength, durability, but flexural strength wasn't.
Flexural is the problem because it gets too stiff when you are adding cement, not properly added. Bituminous emulsion, if you are using it, the flexibility will still remain. That is a good advantage that you have correctly pointed out. Yes. So if you can come up with that as an option, of course, after discussing with all your higher ups and everything, you can even try trial patches or even trial sections and see if it is working. That would be a good addition as well. Huh? Cost is, I mean, I'm not, that's what I said. I would leave that part out of the equation first, cost wise. Huh? It's only OPC, because we want immediate strength, right? I mean, PPC delays the process further. So OPC was chosen, which creates some level of problem because OPC is not readily available. So I believe UP has recommended all contractors that moment your work is awarded, you have to make provisions for booking the cement directly from the manufacturing unit, which takes about 3 to 4 months or 5 months or so that there's a continuous flow.
Thank you, sir. We can have in the open discussion, please. We are short of time.
Yes.
Ideal thing is no traffic should be there. That is what everybody is recommending.
Yes.
Not possible practically on ground.
Practically, yes.
By the time I would say even the pad foot roller is working on one side, the traffic is moving on the other side, sir. That's the practical reality.
Right. Agree.
So the question is, sir, we recommend 7 days for curing. That is what we say, 3 to 7 days of curing. It means the road is exposed minimum for 7 days.
Yes.
To the traffic.
Yes.
Thereafter starts the test procedures.
Thereafter
starts the test procedures.
Test procedures, scoring and everything, right? Yes. Okay.
Will take at least another, I would say 17 to 18 days.
Ah.
It takes about a month from the time the road started and the time you do a BC.
Yes. So you have to cross the 7-day strength and 28-day strength for you to, yes.
So though the policies have come in, sir, new policies have come in, we are shortcutting this, sir. But now my question comes, sir, that what is the ideal thing that we can do to protect this top surface till the time the BC is being laid? What can be done? How to protect the surface, sir, from wearing it out? People have given different suggestions, but what exactly do we implement on ground, sir? Because you will see that once you are laying the top surface, you are supposed to do 30 mm, sir. Let's say you are using 100 MT. Now you will be using 130 MT, sir, instead of the 100 MT because the top layer has given away, sir. The surface has eroded, sir. So you use much more material than what is supposed to do.
That is a practical thing. I agree to that.
If we have a practical solution to it, sir, just wanted to know that, sir.
Or my answer would be, you tell me what you do in there and I will be happy to follow. So it's a enforcement issue. I mean, I can understand your concern on that. And minor modifications in quantities do come in because of this particular issue. But enforcement is the only way. And when you're working with village roads and those kind of areas, I mean, somebody who is using that road regularly, asking them to not use it is really difficult. I mean, and One other thing would be that rerouting, or I don't know, you might have explored all those things, but not everything is possible. I have to say that. On closing out, police.
For this question, there are some suggestions.
Yes. Huh? Yeah, fine. Not right now, not in this platform. We can always do that. We can always do that. Because there are so many others waiting also.
Thank you, sir. Now I request Dr. Vishnu R. sir from NIT Warangal to hand over the momentary to Shyam Nair sir.
Yeah, okay. Will not leave you. Shyam Nair, in fact, second from Kerala. അപ്പോൾ ആർക്കെങ്കിലും കൂടുതൽ ഇന്ററാക്ട് ചെയ്യണമെന്നുണ്ടെങ്കിൽ ഹീസ് ഹിയർ ഈ സപ്പോസ് ടു ബി ഹിയർ യെസ്റ്റർഡേ ബട്ട് ഐ കുഡ് മേക്ക് ഇറ്റ് ഓൺലി ടുഡേ. അതുകൊണ്ട് ശ്യാം നായർ നമ്മുടെ ബ്രിജേഷ് ദുബെയുടെ കൂടെ യു പിയിൽ വർക്ക് ചെയ്ത് എക്സ്പീരിയൻസ് ഉള്ള ഒരു ആളാണ്. ഓക്കെ, പ്രാക്ടിക്കലായിട്ട് കൂടുതൽ പറഞ്ഞു തരാനായിട്ട് എഞ്ചിനീയേഴ്സിന് ഡൗട്ട് ഉണ്ടെങ്കിൽ അത് തീർച്ചയായിട്ടും അവർ സാറുമായിട്ട് ഡിസ്കസ് ചെയ്യാം, വിഷ്ണുമായിട്ട് ഡിസ്കസ് ചെയ്യാം. അതുകൊണ്ട് ഉള്ള സമയം നിങ്ങൾ ഇവിടെ ഇന്നൊരു ദിവസമാണെങ്കിൽ കൂടുതൽ ഇൻട്രാക്ഷൻ ആവശ്യമുള്ളവർക്ക് അത് ചെയ്യാവുന്നതാണ്. ഒന്ന്. രണ്ടാമത്തെ കേസ് അടുത്തത് അഞ്ജൻ കുമാർ. നെക്സ്റ്റ് പ്രസന്റേഷൻ ഈസ് അഞ്ജൻ കുമാർ. അഗെയിൻ ഹി ഈസ് ഹാവിംഗ് good experience at Assam, northeastern terrain, like which is more or less similar to Kerala. So you can have more interaction. And all these four companies, they have the stall here. You can see but listen how this technology is demonstrated. You can you make use of that exhibition facility also. Now we'll break for the quick break for 10 minutes and we'll come back for the next session.
Disciplinary testing facility in alignment with global standards and technology advancements to meet the increasing demands of their customers for quality reassurance. We are Matter Lab. Wholly independent professional and technical services provider for everything concerned with quality and performance of materials and products. What we offer is a bold promise of certainty to those sectors where failure in service is simply not an option. Our exceptional testing facilities are a testament to our promise.
Roads. When required, a corrective aggregate is distributed onto the surface of the existing pavement prior to the recycling operation. This is subsequently graded to ensure even distribution. Corrective aggregate added ensures that maximum density and strength values are achieved. The recycling process is carried out by specialist equipment that include the recycler, bitumen emulsion tanker, water tanker, grader and roller. Following the grading operation, the recycler mills or pulverizes the existing road surface to the target depth, mixing it with the corrective aggregate to form a new granular mixture. The design process determines the depth of material to be recycled following sampling of the existing pavement. The full recycling train adds the required quantity of water to obtain the optimum moisture content and adds the required quantity of bitumen emulsion inside the drum of the recycler to form the new cold mix asphalt material. The recycling process is carried out in full compliance with the IAT's best practice advice for cold in situ recycling of low traffic volume roads. The applied newly formed cold mix layer is graded to the required profile and compacted using a roller to form the new asphalt pavement layer in preparation for a double surface dressing, which is typically 14mm chipping followed by 10mm chipping. The double layer of surface dressing applied will seal the recycled pavement layer from any water ingress and provide the required texture and skid resistance to the finished surface for the road user. From an environmental perspective, in addition to using a cold technique where less energy is required as the aggregates do not have to be heated, unlike what is required for the production of conventional hot mix asphalt, the recycling process also reduces the use of valuable natural resources such as bitumen and aggregates. For these reasons, Colas Ireland is actively promoting cold in situ recycling under our recently launched Go Green with Colas initiative, thereby saving valuable natural resources and reducing carbon emissions. To find out more about Colas Ireland, please visit our website, or if you would like more information on our products and services, please go to the Contact Us section of our website where you will find key contact information. Also, please check us out on our YouTube channel and LinkedIn page to keep up to date with the most recent news and information.
The next session is about to begin. All of you, please assemble back to the hall.
Over the past decade in Ireland, cold in situ pavement recycling has become an increasingly popular technique for the maintenance and rehabilitation of local and regional roads. When required, a corrective aggregate is distributed onto the surface of the existing pavement prior to the recycling operation. This is subsequently graded to ensure even distribution. Corrective aggregate added ensures that maximum density and strength values are achieved. The recycling process is carried
The next topic for the presentation is the FDR tech implementation in Kerala. The session will be handled by Shri Murali LS, Principal Consultant from KIIFB. To introduce the speaker, I would like to welcome Dr. Shalini U, Scientist, NATPAC.
Good morning, one and all. It's my pleasure to introduce Mr. Murli LS, Principal Consultant on the Technical Inspection Wing of KIIFB. He has worked as Head Roads and Airports Department in L&T Infrastructure Engineering Limited, Chennai, a consultancy firm under L&T Group before joining KIIFB, where he worked for about 20 years. He has started his career with NATPAC, New Delhi, and subsequently worked in consulting engineering services, New Delhi, for about 10 years. Mr. Murli is currently leading the technical services coordination team under KIIFB, a unit which is providing technical hand-holding and assistance to the SPVs implementing infrastructure projects funded by KIIFB. I welcome you, sir, for delivering your talk.
Thank you, Shalini. Good morning to all of you. So I am representing KIIFB, now who has taken up some FDR projects in the state of Kerala. So just want to have a short introduction about KIIFB. Most of the people sitting here are aware about KIIFB, but for those people who have come from outside Kerala, would like to just introduce what is KIIFB. So Kerala Infrastructure Investment Fund Board was established as the principal funding for the infrastructure projects in Kerala by an act by Kerala State Assembly in the year 1999. And through various functions provided in the act, KIIFB aims to channelize the funds for development of infrastructure in the state. And in the year 2016, that act was amended with more powers to KIIFB and covering more areas in physical and social infrastructure. So the fund was established with the main objective of providing investment in projects in the state in areas like transportation, water sanitation, energy, social and commercial infrastructure, IT, telecommunication, etc. And KIIFB's function include assisting various government agencies because we implement projects through special purpose vehicles, which are different organizations of the government, or different departments or organizations of the government. Through them only we are implementing the projects, and we provide them the technical support. Then we are the agency, nodal agency for scrutinizing, approving, and funding major infrastructure projects in the state. So KIIFB, along with the development of infrastructure, we are aiming at implementing advanced technologies and sustainable technologies, there are various things we have tried in the state, which include FDR, then geocells and cellular confinement, soil nailing, that is soil nailing techniques, microsurfacing, permeable pavements, segmental block reinforced earthen wall and geogrids, precast pre-stressed concrete pavements, hydroseeding, ultra-thin white topping, all these things we are trying, or some of them are implemented also. I don't want to get into this. This you have seen for the last 2 days. You are seeing this thing only, so I don't want to talk on this. How FDR helps in reducing the pavement thickness. See, in KIIFB, we have implemented a project as a pilot project in Anedi Padakulam Road in Pathanamthitta district, which is around 5.9 kilometers length, which this technology is implemented, and the project was completed in the year 2018. So when we are doing that at that time, when we tested the conventional pavement method or the pavement design, the total thickness came to around 540 mm. And when we did the design for FDR, the total pavement thickness came to 340 mm. So, and we are using the material which is available at the site itself, thereby reducing the requirement for virgin aggregate. I don't want to repeat the same thing again because you are hearing it from the experts who have implemented the project, and the research people, academicians, researchers and all. You are continuously hearing this. I don't want to explain too much on this. So what I explained, the total length of the road was 5.9 kilometers, and 4% the binding agent cement is 4% which is added. And the stabilizer which is used at that time is stable road. So all what you heard previously also, pulverization, compaction, grading, compaction, all these things were done with a varying course of 40 mm. That is what was done. So this process, so many times you have seen. Again, I don't want to go one by one. So you have seen all these things in various presentations. You have seen how the technology is implemented. And a core test was also taken at the end of implementation. So minimum compressive strength for the stabilized, what we got in the site is 7. And as per IRC 37 2012, what the requirement is 4.5 to 7. Then we have conducted FW survey subsequent to the implementation, one immediately after the implementation, and in the year 2021 again we did FWD analysis, and the results have found that see, all sections have got good, almost same conditions, road conditions and pavement composition, and predicted predicted traffic, the life for the pavement is much more than what was aimed at the time of doing the implementation of the project. So the remaining life of existing pavement based on the reliability, 80% reliability, is found to be safe, and hence overlay required is not, there is no overlay required at the when we did the FWD. So what is found is that for the period for which the pavement is designed, even though it is designed for 10 MSA, the analysis showed that it can carry much higher traffic in terms of MSA. So this is the present condition of the road after this photo was taken last week. After 5 years of implementation, the condition of the road is like this. So advantages again, I don't want to repeat the same thing what you are hearing repeatedly, the advantages of FDR. So even though we prepared this one, it will be boring if you again and again repeat the same thing. So Now coming to KIIFB funded projects, we have taken up implementation of FDR in 9 roads already. The cross section what we are following is 5.5 meter carriageway with 0.75 shoulder with on either side with a train come footpath of 1.5. So these are the list of roads for which FDR has already been awarded, and 95 kilometers of roads have been awarded, and work has started in Kollam district, that is in Patanapuram Menath stretch for 14 kilometers work has started, and for other roads the preparatory work is going on, and in Trivandrum also the work will be started. Trivandrum district work will start soon. And subsequently, we are thinking of taking of FDR projects in another 20 roads covering various districts in the state. So this preparation of DPR and that process is technical sanction, all those process are in the advanced stages. So in conclusion, full depth reclamation in particular has got great in terms of savings in time, energy, material and cost. So through interventions of KIIFB, we could commence this environmental friendly process in the state of Kerala. So with the adoption of FDR technology, there is substantial time, cost and material saving in construction. So what we are looking for now, like with the savings what we are getting from these projects, we will be able to take up more jobs. And this is basically we have taken these projects in low volume roads with traffic less than 10 MSA and the CBR where CBR is more than 5%. So this is a short presentation. I don't want to get that. Basically, we want to show what is the list of roads we have already taken up and what is coming up.
Thank you, sir. The floor is open for one question. Otherwise, we'll move to one question.
Yes, yeah, correct. Yeah, you are talking about in terms of cost?
No, everything.
Yeah, I think the riding quality,
Riding quality will be all fine. In terms of its performance. Yeah.
That's what.
Adjoining road?
Adjoining, see, this particular road only a small section of that road is taken for FDR. Balance is done in the conventional method only.
So how do you compare?
So that's what this is showing, like the life, longer life in this it is showing
only
longer.
2 years now.
After 5 years.
And then what happened 2020 onward that the COVID related what is that the lockdown and other things were there. Traffic was there for about 3 years. Okay, and maybe this is the time we should.
But they also done the FWD recently.
That is it.
Yes.
Probably we'll share that one later, not now. we just started that. This is something in the section.
Yeah. Pilot project.
9 kilometers. No, that we are doing. NATPAC is doing. Session is over.
Thank you, sir. Now I request.
We can have more discussion in the afternoon.
Now I request Dr. Anil R, HOD, College of Engineering, Trivandrum, to hand over the memento to Shri Murali LS as our token of love and gratitude.
Thank you, sir. We'll move on to the next session by Dr. Anjan Kumar. He is faculty Civil Engineering Department, Assam, India. His research interests include hot and cold and payment management systems. Dr. Anjan's research team works on whole assessment of reclaimed materials, interaction in bitumen mapping roads, infrastructure development, intelligent compact risk-based management systems. He has been active with forensic investigation payment failure, roadway designs, and advising consultant to road developing agencies in India. Dr. Anjan has several research publications in various referred international journals proceedings. He is a state technical for Assam and Meghalaya National Rural Infrastructure Development Agency.
Thank you. Very good morning to everyone. Thank you, Shalini, for the introduction. Last 2 days, time totally what is an process, how to implement, what are all the. Today, I will be discussing with you some of my limited experiences in exploring the FDR applicability, suitability in the North states. What preliminary analysis we have done, what we found, and how we plan to implement that in a large scale. And our experiences, we are confining to mostly to the rural road because we found an opportunity to start exploring this, the challenging terrain of the North, especially rural roads, where the risk of failure is as high as when we anticipate the risk of failures effects in a higher categories of roads. And also a possible reason is agency account the implementation of new technologies. When I see this figure, I always get wondered about myself, even though Indian guidelines have been there in 1960s or 1980s before I graduated or before I decided to become an engineer, we haven't utilized fully the stabilization techniques. But now the time has come for us to go look back, go search for the possible ways out to achieve some sort of effectiveness, either in cost saving, material saving, totally, in total to meet some sustainable goals. That's why I have titled the as it's like, full depth reclamation techniques for sustainable roads. I will not go into the much more details about, but let us recollect why additive based technique was selected. However, the four area of full depth reclamation is unstabilized technique, stabilized technique, additive based technique, and based technique. Most commonly adopted is additive based stabilization, as the FDR is the process of reclaiming the existing material. It is to be not confused with the conventional stabilization process, where in the conventional stabilization process, the origin materials are processed within selected additives and constructed as a fresh layer. But in the case of FDR, using the existing material. So 4-step process we have been discussing since yesterday. I will just list it and skip apart now, and I will just present you what is that we have done in the Northeast. The 4-step process is, first is pulverization, mixing, compacting, and then providing a wearing course. As it has been said as a 4-step process, this is not so easy to be implemented, this is not so easy to be selected, and this is not so easy to be designed. Even in a small PMGSY road, small means in terms of traffic, in terms of the geometric constraints what we face, a lot of dilemmas, we had a lot of challenges to arrive at a proper framework where we can implement this FDR technique. I'll just skip the benefits. I'll straight away start with the FDR framework, what we adopted in the state of Assam. I acknowledge the support extended by 15 members were involved to arrive at the process. How do we start this FDR process? Starting from the planning stage, design stage, and we have crossed only design stage. We haven't started the implementation stages yet. So first is we have to do a desktop study or a field study. See whether a candidate project is suitable for an FDR technique. Yesterday we have understood where it is suitable, either in terms of distresses or payment failures or due to a geometric deficiency. Geometric deficiency could be your surface drainage issues or the camber issues, profile In that case, it may be a FDR candidate. The next process is to ask our maintenance record, to ask ourselves whether such roads, the patchworks or the maintenance are not effective. That gives an indication of the structural failure of any pavement section, mostly the base and the sub-base layers. Then comes, as the previous speakers have been told you very detailed, whether is there any drainage issues. The question may again raise towards the end of this session or towards the when we talk so much about drainage from the decades or from the day of highway engineering, why are we not considering the drainage issues in FDR? There are some possible assumptions and considerations. Your pavement structure is subjected to saturation. In this, FDR may not work. Most importantly, is the existing subgrade right or good enough? If there is a subgrade failure, for example, most of the European countries, they have a check to ensure that subgrade modulus is not less than 40 MPa. So if your subgrade modulus is less than 40 MPa, that indicates a subgrade failure. That indicates in very common terms what we use to characterize our material as CBR. That CBR of that material could be less than 3. So in that case, FDR is not the solution. So any no to any of this framework, FDR should not be used. If it is yes, then only an FDR technique could be adopted. So this is the typical candidate projects where I have just visualized here what are all the steps we followed. We saw the framework where we see frequent patch-ups failing, repeated patch-ups failing. This is a typical 1 or 2 illustrations I'm seeing. After identifying this is a candidate project, the next question started asking ourselves is, what should be the FDR depth I should consider? What should be the additive I should consider? So then we started looking, most of our PMJSY routes, we know that we are providing only bituminous surface treatments. And definitely, if we are calling that as a FDR candidate, there won't be any bituminous surface. Definitely it would have been washed out. In some cases, there may be projects, a distressed bituminous surface, maybe in some of the higher category, even in the low volume roads where some states would have been provided a dense graded mixes like in previously semi-dense bituminous concrete or now what UP is as a 30 mm BC. In such cases, some bituminous layer could be present. Then should I consider both bituminous as well as the base layer? Then we had one more, whether I should also consider my sub-base layer or full sub-base layer, or should I consider touching my subgrade? So when we have various scenarios, the risk also follows you. So the risk here is relatively less when you go and confine your FDR to the layers which are failed. Mostly our base layer would have failed in case of rural roads what we anticipate. If the sub-base layer, the risk is low, not only because of your design, structural design or your failure confinement to only base layer. The risk is low because implementation is easy, rehabilitation is easy, and also further addressing the failures of FDR, find the FDR depth to the problem associated locations or the problem associated depth alone. If we go with the higher depths, the risk is substantially high, especially when you touch subgrade. For example, in most of the FDR techniques, we are going up to a depth of 250 millimeters, 300 millimeters. Suppose today you compact a subgrade stabilized layer of 300 millimeter to the depth and you provide a SAMI or you provide a bituminous surface treatment. Further, in the years the lane, 5 years, 10 years, if you have to rehabilitate or strengthen that layer, up to what depth you will do a milling, up to what depth you will be doing a recycling. Eventually in the next decades, we all will be recycling the existing pavement where we don't have any virgin materials. In that cases, addressing this becomes a big nightmare for all of us. And one more challenge, even at today, when we have soil, when we have granular material, when we have bituminous material, all materials are different. And the variability imparted by the composition of this material, proportion of this material, the material inherent properties to the FDR process is nightmare. That's why we have to be very careful when selecting the project and the depth of reclaiming we are deciding. This will also answer us what type of additive we are using. When we did this exercise, we were carefully looking at what type of additive we should start. There was a very good question. Why go for bituminous emulsion? Definitely you can go for bituminous emulsion or a cold process. But in our case, what we saw is our material was more a granular material. Emulsion based reclamation techniques would be cost effective when we have a substantial portion of reclaimed asphalt pavement material in that. In our case, it was PMGSY roads. The reclaimed asphalt pavement material portion was relative. And the second important thing is when you have a finer material, when you want to go touch your subbase material, okay, your emulsion content or the proportion required is substantially high, where your cost economics may not allow you to select that. The third important material characteristics what we anticipated in case of Northeast is most of our subbase was constructed using granular naturally available subbase material. And our source is river run aggregates. As I say river run aggregates, there is no control on the composition or the material properties. Sometimes the composition, it might be quartz, it might be segmented material, or it's a river run material. So entire composition varies. Today, we haven't benchmarked the chemistry of bitumen. And as I say that, the emulsion is a much more complex material than bitumen. So it's not easy to play with the emulsion when you doesn't have a proper understanding or proper information of the material where you will be using. That's why, considering the risk associated with the depth we need to adopt, the additive we need to select, and provided most of our material what we have investigated was relatively non-plastic and a granular kind of material, we selected cement as the additive. Field sampling. So this is how test pits were taken. We have taken 6 test pits minimum per kilometer of a 3-meter PMGSY road. That is to ensure proper representation of the is considered. In most of our roads, which are 10 years old, 5 years old, 15 years old, it is not like in documented organizations we are running. Go debug any construction history, construction records, nothing is available. Even a kilometer to kilometer, the material source would have changed, the proportion would have changed. Somewhere the compromises between grading 2, grading 3 would have done. All such informations were missing. So we have to go and do a rigorous sampling, at least minimum test pits of 0.6 meter by 0.6 meter up to the depth of subgrade was excavated even in for PMGSY roads. And during excavating, we carefully selected the important information, that is the amount of moisture present in each and every layer. There is a question like if it rains, what happens? If it excessive moisture happens. But if you are treating with cement, the in-situ moisture content available could be relatively almost close to the optimum moisture content or the moisture content required for your cement stabilization itself. Why? In case of PMGSY roads, the bituminous surface would have totally started and disintegrated. Whenever it rains, entire pavement structure becomes saturated. So relatively the moisture content would be substantially high in these layers, which we have to consider while selecting the additive and planning our construction activities. If it is rains, no construction activity. It was written in 1980s or when I read my first textbook in highway engineering. And sampling procedures are given as guidance, not as mandatory. So as rightly mentioned by the previous speakers, visual inspection is must and mandatory. Your visual inspections will tell, which give you the guide back what type of sampling you should adopt, whether I should go to 2 or 3 or 5 numbers, whether I should take a sample here or sample there or not. So that governs and guides by your visual inspection of the project. Definitely at the time of sample collection and sampling, you have to ascertain. You can do a simple testing like what I have shown you here as a DCP. You can collect a relatively sample of the material. You can assess the moisture content and its density using DCP and any of your density measurement at site at all test locations. That will give you an idea. My pavement is not failing because of any subgrade issues. Because in our case, it was a PMGSY road. Hardly we had a crust of 200 millimeters to 300 millimeters. And these crusts are the crusts which bear the load. And if we assume that the failure is only because of these granular layers, then we might not fully correct. That's why in all the projects, we have to ensure there is no subgrade related failures. So then started collecting the sample, bringing it to laboratory. Then we looked at ourselves. The information was totally absent. What type of gradation I should adopt for reclamation, FDR. Can I directly borrow from some of the Western countries? Yes, they have the process, but we have to accept. Other than India, I'm not sure anywhere in the world they are practicing WBM for granular layers, at least for paved roads. Only forest roads, farm roads, or recreational areas, they may use these methods, but not everywhere. But what we refer the guidelines developed by the American practice or European practice where the WBM was not used, and we cannot take that gradations directly. So we have to do a lot of exercise to arrive at a consensus gradation, what I can adopt for a PMGSP road. So in that, something is already handy with us in the IRC guidelines. If you see, we have many guidelines available, starting from IRCSP 2010, IRC 37, MORD, even MORTH specification is also there. The MORTH and IRC 37 specification is almost the same. So we had various combinations. And clearly, even in the stabilization process, these are all recommended for stabilized layers, either a soil treated with cement or fly ash or lime. So if you see, the particle size distribution varied from as high as 75 mm to 75 microns. So this gave us an idea, yes, we can restrict or we can adopt larger sizes also, unlike what it has shown in the literature. So if you see any of the FDR guidelines developed elsewhere, so you will see 100% passing 75 mm, 95% minimum passing 50 mm, 55% minimum passing 4.75. In PMGSP roads, if you use any material that is 55% passing 4.75, such roads may not last according to my limited experience. Because in our PMGSP roads, structural layer is your granular layer, not the bituminous layer. And if you have such a fine-grained material in such layers, our roads would not last. So technically, such gradations may not be suitable for our practice. Then comes the current stabilization practices available in the MOH, where for a fresh material, suppose if you want to produce a cement-treated base or cement-treated sub-base, some gradations have been given. In order to adopt that, I have to have an in situ material meeting this gradation. Most of us know, I have seen many of my friends, STAs and all, we started using WBM grade 1, where the nominal aggregate size itself is 75 mm. Now we cannot have a practical sieve during the reclamation process to take out all that aggregates. At the same time, we should find a way whether we can substantially use that or not. So then we proposed it. Most of the projects, what we have seen is 75 mm is maximum passing, and 1 or 2 projects, negligible proportion are retained on 75 millimeter. So from 75 to 75 microns, we have come up with some gradation bands which can be implemented as a trial basis. So for that, for collecting this entire state, we have zoned. If you see this color coding is done by the practicing engineers, where they found that the relatively source of material, the traffic composition, the crust composition, and the choice of pavement type was relatively similar in these zones. In such zones, we have technically identified 4 or 5 projects. From that, projects were selected for case studies as laboratory mixed design evolution. So we adopted the gradation for these projects. If you can see, the gradations what we have proposed almost meets our MORTH requirements as well as MORD requirements. Only catch here is the gradation what we have proposed allows you to accommodate larger sizes up to 75 millimeters. So then the routine process, bringing the material to laboratory, do a rigorous sampling, sieve analysis, determine its soil moisture relations, that is your MDD and OMC relation, identify what is the optimum moisture content to orient this material under a given compacted forces to a dense mass. We tried with additive, without additive as well. For the gradation and for the materials, in any of our projects, we didn't disturb the subgrade. Subgrade was not included. So for this, with cement or without cement, we didn't find much deviation in the MDD and OMC characteristics, because relatively the cement dosages, what we started as a trial was relatively less. However, it can be done as a project specific mixed design exercises, where with additive and without additive, determination of moisture density relations are very, very important. what is the target strength I should jump away and adopt? Is it 4.5 is safe for me, or it is not adequate, or can I go for a lower values? So when we reviewed within the country, we have a lot of information available which can guide us what should be our target. So you see MRD, Ministry of Rural Development. So clause number 404.2.6 says that in case of subbase, a cement treated soil, you can have a UCS value of 1.7, and in case of base 2.76. Likewise, if you see IRC 37, which is written for a higher category of roads, says that for a base layer 4.5 to 7 MPa. Yes, NRDA guidelines has given you this 4.5 MPa. Considering various challenges, various variabilities, this is the guide it has recommended, and we also went with target of 4.5 MPa to achieve in the laboratory exercise. Yes, we casted the UCS specimens and we determined the appropriate cement dosages required for various projects. Across around 96 mixed designs were carried out in the laboratory, including the durability test. The durability test, we practiced the method 1, which is an immersion method, where you have to cast your specimen and continue curing in the natural process, maybe a wet sand curing, or you can immerse that in a dedicated environmental chamber, and the one set you will immerse it in a water bath. Then after 14 days, you will take the ratios of your unconfined compressive strength, and if the retained strength is more than 80%, then it meets the durability requirement. If not, the next method, if you feel that your project location experiences rigorous variations in temperature as well as the rainfall, if it is a snowbound, you can go for wet and dry cycles or freeze and thaw cycles. In any case, the mass loss should be less than 20% for base layer, 30% for sub-base layer, and even for hard shoulders, which is most essential for hilly regions like Northeast. There also you can go for these materials where the durability criteria is mass loss should be less than 30%. When we did these exercises, okay, if you can see, almost all mixes met the durability requirement. We didn't have any challenges in accomplishing the durability with the gradations what we have proposed. And that was various additives as well. So with that, I'll just come to the construction. So I'll just summarize what we have to keep in mind. That is, as we have been aware from the last day. So these are all the fundamental control factors what we need to consider. That is proper cement content, adequate moisture content, thorough mixing, adequate compaction, and proper curing. These three, we don't have an expertized process in this, then we cannot achieve a reclamation process. I'll just summarize this and I'll go to the last component. So now whenever I go, people start asking, why are we showing these fancy rollers, or why are we proposing pad foot rollers? No, I don't think this is the first time we are proposing anywhere. These pad foot rollers, ship foot rollers was there everywhere. Why it has on full depth reclamation here is, we need to understand when we use a vibratory roller, spool drum roller, the compaction process is from top down. But if you use a pad foot roller or a ship foot roller, the compaction process is from up. It is very easy to ensure the process starts from the bottom up. That is, the lower part is compacted. And when once your target of full reclamation is more than 200, which cannot be achieved with conventional vibratory rollers. That's why the use of pad foot rollers or ship foot rollers is compulsory in case of full depth reclamation, where the reclamation is more than 200 millimeter. So after process, yes, any typically bituminous surface treatment suitable for rural roads, either it could be mix or hot mix, or sometimes concrete. I would like to just give one considerations what we have considered in the Assam and the trial cases. We have been discussing about the SAMI, whether it's suitable and further reclamation process, whether SAMI is better or a crack relieving aggregate layer is better. In most of the low volume roads worldwide, they practice something called micro cracking. Okay, micro cracking is a process which will mitigate formation of large reflective cracks by inducing micro cracks. What causes reflective cracking in a stabilized layer? We all have understood and we all are aware, but let me summarize some of the factors. Compacting this stabilized material at a relatively higher moisture content. When you compact this full depth reclamated material, more than plus 1% of your optimum moisture content, definitely a reflective cracking could be a concern. But in the field, definitely there is no tight moisture control within our construction community, implementing community. So that's why the reason where the reflective cracking become major concern in case of stabilization process. Higher percentage of clay. When you try to dig your soil, then you are inviting yourself trouble in case of full depth reclamation. And if the soil has substantial portion of clay, it is definite that reflective cracking causes probabilities are relatively high. Rapid moisture loss, failing to achieve required compaction, and excessive amount of additives. These are all the factors of which can accelerate or which can invite troubles in terms of reflective cracking. What we can avoid is introduce micro cracking. So how to introduce micro cracking? I'll just show you in one more slide. Before that, some methods to mitigate reflection cracking is, first of all, we have to adopt a sequenced construction practice, compact slightly at a lower or at optimum moisture content. Don't use excessive amount of additives. When we do this simple mix design, we have to ensure that mix design can be implemented by doing a trial section. In the trial section, you have to vary your optimum moisture content as well as optimum additive content. It cannot be soul and soul dependent on the laboratory, because as we know, laboratory is a beautiful air conditioned 1000 square feet laboratory, but your laboratory is your road. So there you have to recheck and revalidate the requirements of moisture or the requirement of additive. Curing is very important. It has to be started the day of your stabilization. Most of the times they will tell we start curing from the afternoon. Construct your house, you construct your concrete, your slab, and you will start curing the day night. But for the road, we will wait for 1 or 2 days. Why? We all know the answer. So right amount of cement or admixtures, curing, and delay surfacing is some countries they practice. There was a question, sir, if we allow traffic. No, such traffic means which doesn't cause any structural damage to the constructed pavement. So such traffic can be allowed. Light traffic, that is non-commercial vehicles, may be allowed, which is predominant in case of our rural roads. I am not sharing this or generalizing this experience to a national highway or a higher traffic category roads. In case of low volume roads, where predominant composition is not commercial vehicles, there the delay may help because the shrinkage cracks or the shrinkage phenomena would have subsidized. Then you may have to go with a stress relief layer or pre-cracking. Pre-cracking is a process of introducing micro-cracking. Immediately after stabilization, 1 or 2 days later, if you have a smooth drum vibratory roller, you can provide 1 or 2 passes of roll with low amplitude. This will introduce micro-cracking, and this will avoids or mitigates the risk of large or wider reflective cracking. Some countries, they do practice this micro cracking and found to be very effective for low volume roads or cement based FDR techniques. We are also in the Assam, we are also not proposing SAMI, because even IRC 37, IRC 72 very clearly says, it is defined in the guidelines, when your traffic levels are less than 2 MSA, you don't require any SAMI layer. And if it cracks, let it crack, let us learn. But providing an higher or a conservative crust, we cannot evaluate the recycling process, especially in case of rural roads. That's why we are going with this micro cracking process. Maybe a year later, when I come and share the experiences after 1 year, I may share with you whether that worked or not when we try to introduce this in the Northeast. So this is all about a very quick presentation about our experience in the Northeast, how we did this exercise, and so far how we are able to achieve a proper mix design with cement as the additive. So construction machineries, all this has been discussed. Yes, we need a reclaimer definitely. An additive spreader, either a cement spreader, motor grader is required. Use of vibratory pad foot roller on the steel drum soil roller, single drum rollers, soil compactors are very, very essentials. We should not use any tandem rollers, we all know that. Pneumatic tile rollers are also required where the pressures are high and the depth of the layer compacted could be relatively better. Excavators are required when you have to handle with your shoulders. There is a practice where often go mix the shoulder with FDR. No. And in India, we know shoulder is not constructed with the materials which are supposed to be. Everywhere we go, share the photos, take the photos, the failure of shoulders. And when you take that material and mix it to your FDR process, you're inviting trouble again. Either you will go increasing your additive dosage or bring in multiple choices of additives because your material has degraded. That's why excavators may be required when you have to separate out inferior or poor materials contaminating your FDR process. Water tanker, yes, definitely we need to maintain the moisture content. So some quality control tools I'll skip here. So this test statistic I wanted to share with you before I conclude. If you carefully see the variation in the strength in a controlled environment, what we have seen in the laboratory, almost, if we are targeting around 4 MPa, 0.5 MPa is the variability. That means in the field, your variability could be relatively higher, which you have to be careful. When we develop a specifications or when you give any quality control limits to a contractor or to an acceptancing agency, we have to be very careful about this. When in the laboratory it is 0.5 MPa, maybe in the field it could be about 1 MPa. So when in the case of rejection or acceptance, you have to have such information from your mixed design process or routine testing process. This is not in limit I am proposing, but this is the information I am sharing so that this has to be developed over evolution. So with this, I would acknowledge again PWD Assam, NRDA, MORTH, MORD, relevant IRC publications, ASTO publications, Sport Association, Federal Highways Administration, United States, ARRA, and open web resources. So I thank all of you for giving your time. So I
thank you, sir. Thank you. 2 or 3 quick questions, please.
Sir, sections with this micro cracking, could you elaborate a bit more on that? So did you had control sections?
We are constructing the control sections.
Okay.
We
And when you say about micro cracking, say, have you checked what is the depth of this crack?
Depth of cracking in the wherever they have already implemented that. Okay, what they have seen in a 6-inch layer is the depth of cracking is normally 1 to 1.5 inches, and it is totally interconnected, and it is not only confined to surface. Sometimes from the bottom, sometimes totally heterogeneous in the layers.
So basically, when you micro crack this is again gonna be something like a granular layer. Granular layer slightly bigger.
Okay,
slightly bigger boulders.
Maybe when a higher level of micro level cracking, it may eventually be a granular layer.
Okay.
At a very low level, because of the concrete will be young when you are doing this micro cracking at the first day.
Okay.
Because of the hydration and the healing process, micro cracks can bond it together. It will only relieve your shrinkage stresses when you introduce this micro cracking.
But majority of these chemical additives, they claim that they could reduce shrinkage.
Definitely, maybe, yes.
Yeah.
The road.
Yeah.
I'm happy it reduce.
Thank you. Thank you.
The first one you said something like less than 45 MB or something, no? First few slides.
I'll go to this.
Initial stage where you said.
Oh, in the title slide somewhere?
Yeah.
Okay.
Yeah, is existing subgrade stiffness less than 40 MB means what?
The subgrade soil properties, whether it is a weak soil or not, we'll investigate.
If you say 40 MBA means what? CBR.
So CBR of 3, that's what I mentioned. If you have to convert that, if the CBR is less than 3, that indicates it is a poor subgrade.
So CBR of 3.
Yeah, I'm just transferring to CBR. 4 is based on the shell design. Some literature also tells that less than 3.
No,
but if you are equivalently, it is 4. Equivalent, it is 10 times your percentage.
It is greater than that.
Then the subgrade material is not a weak material. Then you have to check density and the moisture content of the subgrade. If the density is...
So in that case, you don't recommend the FDR?
Yes. If it is a poorly compacted subgrade and poor subgrade, I don't recommend FDR.
What is the solution for such things is what you go for?
You have to reclaim the material, take it to a stockyard, rework your subgrade and use it as a central plant reclaiming or recycling process, perfect process. In my opinion, FDR may be worldwide adopted, but we have to fine tune to our requirements as well. So if our requirements, such powertrains are not working in Northeast, we don't have to go for a technical powertrain process itself. If a reclaiming and working in a controlled manner in a plant is more suitable and more cost effective for you, that is obviously followed. We can call it as a FDRRP, full depth reclamation recycling process. Nothing, everything has evolved.
I think you will have to really explain this because everybody is going in for an FDR.
Uh-huh.
So this is something which, when you say the CBR value is less than this value, only you go for FDR. That's what you say.
No, no, no. When the CBR value is above that. In situ only. What? In that scenarios, okay, you have to reclaim the process and shift it and rework your subgrade.
Need not be
In situ. Otherwise, the one more alternative is when you know that if your subgrade is weak, provided it is only inferior material, but density and compaction requirements are met, then don't go touch your subbase layers and introduce higher stresses on such layers. Okay, instead of that FDR, you provide additional layers where the amount of stresses coming on the subgrade layer could be relatively less. That itself indicates that FDR is not a candidate technique for such projects. Yes, that's what I have shown you. I mean, I have shown all those identification process. Definitely, yes. Right. Very straight. That's all it is. Simple.
I think there are a number of questions. We can discuss remaining questions during the open forum. Thank you, sir. Thank you for the wonderful presentation, interactive presentation.
Sir, now I request Shivkumar sir from NIT Calicut to hand over the memento to Anjan sir.
Okay. Thank you. Thank you.
Next we have with us Professor Dr. A. Veeraraghavan, retired professor from IIT Madras. He'll be handling topic issues and challenges in FDR implementation in India. To introduce the speaker, I would like to welcome Anish Kinir sir.
Thank you. I think we have 40 minutes to go before the lunch. Lunch may be slightly delayed. Nonetheless, I think we have heard from number of speakers about the full depth reclamation technology. So yesterday when Anjan was asking me to share the presentations made yesterday, I told that there is nothing new. The concepts, principles remain the same, the steps remain the same. Every speaker will tell the same. But what is new? So my job at this point of time is posing questions. So that's a very simple, easy job. So I told that that's what I wanted to tell yesterday itself. It's a unique workshop in which neither the speaker nor the audience knows the solution. We are all sailing in the same boat. If you ask me a question, I don't have an answer. So mainly, I accepted to be present here to learn the process from you and also sharing of the knowledge of the best practices. So let us, I will pose a number of questions. We will continue the questions after lunch as well. I hope that by the end of the workshop, you will go home with solutions to all your questions to the extent possible. I don't guarantee that you will get answer to all the questions. So generally, as we talk about the FDR technology, full depth reclamation technology is one of the rehabilitation technique. That's what even Suresh was mentioning. You have to go to the root cause and find the solution. Is FDR is the only solution? The answer is no. FDR is one of the solutions. Conventionally, what we have been doing is that we have been providing overlay after overlay after overlay. Sometimes we mill, most of the times we do not mill. So we provide some BC40, BC50 or PMC, something we have been doing all these years. What we generally do in a FDR is that we mill the layer, we reclaim the material, pulverize the material, knowing fully well a reclaimer will not pulverize. make it into homogeneous section, compact, so that we get a better quality base course than what has already been constructed. That's all finally we get. So, but at the same time, what every speaker told is that we have to ensure that the supporting layers are strong enough. There is no inadequate subsurface drainage issues. But I always learn the process. I pose within myself the question and also think of the answer. More or less, if you look at I have been successful or not. Fairly, I have been successful because I look differently at every problem that we face. So everybody said that in this case, this will not work. My question always is that how to make it workable? That is, should be the challenge to all the academicians. Even just today morning also, I went to Cochin Airport. There are depressions in the holding area. At that location, maybe about 20 meters, where the aircraft is parked before takeoff, there are depressions at the wheel path. Now the question is that how do you repair it? That's the first question. What is to be done? Second question is that repairing the depression in the holding area in an operational airport becomes a challenge. You cannot stop the movement of the aircraft with a possible time. At the earliest, what we can plan now is that we can start from November 2023. Only then the airport can be closed for a few hours. But with that, you have to give a solution. So I always take problems which others cannot solve. So I derive pleasure in finding a solution. So everybody said that subgrade CBR should be more than 40. Thanks to Anjan, he said that a different technology, how to improve subgrade. We also think differently as how to improve the subgrade without reclaiming either any other way. How to improve the subgrade? That's the first question. Second, people talked about the subsurface drainage. Morning also, while traveling from the Cochin airport, thanks to Shalini, she shared with me the YouTube link. I was watching the presentation by Shyam. He also given that steps to be followed. But every case, this is not possible. In this case, it's not possible. How to make it possible? That is something that we as a professional should think of. Then nothing is impossible according to in my dictionary. Everything should be possible. How to make it possible is an issue. Will it be cost effective is a second question. Will it work is the third question. I always tell that you go to a doctor, you consult. If you're not cured, you don't go back to the doctor. Same is the case in a professional also. Whoever comes to you, you have to give a solution, a workable solution. And that's how they come back to you. So you should think innovative way of solving a problem. There is no one solution to any of the problems. But FDR has been found to be cost effective, especially in a state like Kerala, where aggregate is not available, soil quarrying has been banned. How do you conserve the natural resources is the question. How to improve the durability? At the same time, how to ensure that the life cycle cost is lower? This is again a big $1 million question. How do you predict the performance of this FDR? Will it work? But whatever I have seen so far, we are considering FDR mix in isolation alone. We are not considering it as a payment structure. That's the biggest flaw according to me. You consider it as a payment system, find out the stresses or strain coming in that layer system to get the strain for the design life. You work out the mix, this strength. Even Anjan showed a big table of different strength values of UCS. What is that you need? So everything depends upon the dosage of cement, cost, performance. Many things are related to that. So finally, I think there are many questions that are to be answered. Perhaps we can discuss in the afternoon to find a solution to that. And more importantly, quality. What is that quality test that we should carry out? Just ensuring that 4.5 MPa, does it mean that the payment will last for 15 years or 20 years? I don't think anybody can answer that question. So we are talking about the mix in isolation. We are not considering as a payment structure and then talking about the performance. So as I mentioned, these people have already talked about that. Either I can go for modify the gradation or add a cementitious material, can be a cement stabilization, or I can also use a case of an emulsion or use a foam bitumen. So FDR does not mean, why I'm showing the slide is that FDR does not mean you add cement or cementitious material. So you can add different types. In another way, what I want to tell is that FDR is not the only solution for all distresses. So it boils down to the question, How do you select the project for FDR? It's an unanswered question from all what I have heard so far. Perhaps I'll open up this question once again at 2 o'clock to discuss. How do you select a project for FDR? Well, perhaps Murli also should be able to tell me, how did they select the 9 roads for FDR? Did they consider alternate materials, alternate mixes, alternate designs, and finally arrived at FDR as the most cost-effective preferred technology? Maybe Anjan can also tell from Assam. He also talked about the setup, how they discussed, and then how they arrived at. But did they consider alternative technologies and then arrived at? Perhaps we can discuss that in the afternoon again. So when FDR is suitable, generally when you say that in the PCI value is 55, or distresses or the wheel path, excessive rutting, I'm not talking about how much rutting is excessive. What is the value of alligator cracking that is permissible? This is something that academicians should arrive at. We have to tell if I told 55. You can ask me, why 55? Why not 45? I have no answer. This is something which I feel academicians should work on it. Number of projects are available. You know the distresses as on date. So start your research from day one. There is no need to do a laboratory performance test. Every kilometer of the road that is being constructed FDR becomes a test track. You start from day one. What is the distress? What is the soil type? What is the stabilizer being used? What is the cement that is used? How do you mix design, variability in mix design, and hence go to the performance. So in some cases, the roads are being widened from 3 meter to 3.75, 3.75 to 5.5. In that case, you are not only milling the existing materials that have been already constructed, but you are also adding to that the shoulder material. As Anjan was mentioning, most of the cases, the shoulder is not constructed. We leave to the nature for the shoulder to get compacted. Mainly it is the drain soil that is being filled up. I've shown in many training programs, but nevertheless, specifications are different. What is being practiced is different. But why I'm bringing that is that when you try to mix the shoulder soil along with the milled pavement material, what should be the proportion ratio for that project road? In last, I think 2 weeks back, I was in UP. I think Mr. He was also there. Quality control coordinator was also there. We went and checked. Design is given by an IIT. The design does not give me a value. What should be the proportion of the milled material and shoulder material to be mixed? It gives this is the material, this is a 4% cement. Why? There's no answer. Why I'm bringing that is that when you test that from academic institution, it is your job to tell this is the gradation of the milled material. This is the gradation of the shoulder material. I tried mixing them in different proportion. And finally, I arrived this. The report is complete only with that, not with the final number. We want to know how you arrived at the number. In many cases, you may have to improve the strength of an existing low volume road because of increase in traffic, maybe because of many other reasons, or correct the profile. Perhaps you have to do that. Here again, there's a question that arises at this point of time. By doing the full depth reclamation, this is a $1 million question, which again we'll post at 2 o'clock. By doing this process, will the finished road level of the pavement after the FDR will be the same as that of the road before FDR is taken up? Will it increase? Will it not increase? Is it possible? Not possible. Is it possible to ensure the camber in the FDR layer or not? Is it only undulation that has to be checked? Is it possible to have the exact super elevation? Normally we tell you that the subgrade, subbase, base course, binder course, wearing course, all should have the camber super elevation from subgrade level onwards. But whatever I have seen in UP, I could not find the exact profile. I do not know that many projects have been executed or under construction in Kerala. Will it be possible to ensure a perfect camber in the FDR layer or not? This is something that has to be discussed. And finally, when you try to ensure the profile, will you be able to get the exact profile, exact finished road level as it was before the excavation? Will it remain the same? Is another question. The third question that comes is that, should you add a virgin material or not? That's again another question. In UP, they said no virgin material to be brought in. Will the excavated material meet the gradation requirement? Again, another question, that incidental question is that, what should be the gradation? I am coming to that point. So the many factors come into the choice of FDR. Again, everybody said that FDR will work with the force upgrade. But my question will be how to make FDR workable with the force upgrade. Is excavating the subgrade to 30 centimeter, reworking it, reconstructing it is the only solution, or there any other cost-effective solution? This we have to think. So consider the structural condition of the existing pavement and distresses is some point. So here again boils down to the point, how do you select the FDR project? Based on distresses, based on the anticipated traffic and expected strength. Normally, I was asking Dr. Pateria, how did you arrive with this 250 millimeter? How did you arrive at 300 millimeter? What is the basis? What is the logic? So everywhere, whatever you have said is that it's 250 millimeter. How did you arrive at that number? What he said was that we took IRC SP 72. It made a provision for 200 millimeter or 250 millimeter of a granular layer. So what we thought is that when you mill strengthen it, that strengthened layer will be stronger than conventional gravel. So we adopted 250 or 300. That's it. It's a thumb rule. But I want the academicians to work out what should be the ideal thickness of this stabilized layer and what should be the strength that is needed. This is something that we need R&D by monitoring the performance of the already constructed pavement. So definitely, as Anjan was mentioning, 4.5 and above or 7 MPa, it is likely to crack. But there are service providers who say, I got 10 MPa, 15 MPa, 20 MPa. So they feel that higher the strength, better the pavement. No. Thin layers, higher strength will crack, eventually will crack. So you should take a precaution. Again, Anjan mentioned about the micro cracking. I am also will talk about that micro cracking in my presentation. But at the same time, if you have a very low strength, it may rut. So what is that compromise? That is what I am talking about, the optimal balanced design, which will neither rut nor crack. This is where the R&D should play a role. I request Sunita, Tushar and others who are all here doing research here to work on this, to come out with a design which will neither rut nor crack. The other is that if you have a bituminous stabilized material or emulsion material, definitely it may not have a higher strength, but eventually it may rut also. We don't want rut. If you look at the performance of PMJC roads, I have been associated, Equinchera is associated for more than two decades. So when you look at the PMJC roads, it's not that they don't crack. They may rut. There may be shear deformation, mostly because of inadequate compaction of the lower layers. Maybe because of poor subsurface drainage. I always tell that if you can improve the lower layers, construction quality, the performance will be long-lasting and better. So mixed design process, we talk about the correct proportioning. Mixed design process is a scientific systematic approach, balancing the existing and the desired property. So what is the desired property? Is a question that has to be answered. But first question which I posed is that how do you select a candidate project for FDR? That's the first question. The second question is that we talk about sampling. They talk about 500 meters interval, 750 meter interval, 1 per kilometer. That's what Shyam had mentioned. When I asked Shalini what she is doing, she said that I collected 10 samples, mixed everything, and then did the mixed design. Will that work? That's the question. Okay, I do every kilometer. I have done, maybe there is a variation. What is that acceptable variation in the gradation that says that, okay, I need to mix two job mix formula? How do you decide that? That's what I made a mention yesterday. You should be able to homogenize the sections based on the soil type, based on the traffic, most importantly, based on the distresses. So it may be from kilometer 0 to 2.33. Second may be 2.3 to 4.8, based on the distresses. Then you collect the aggregates. Okay, I collect the material. Anjan was making a mention. Within that itself, there is a variation. So when do you call this variation is acceptable within the limits? What is that limit? This is something R&D should do it. And what is that gradation or the sieve size that matters? Mostly fines. That matters the dosage of cement as well as the performance. So perhaps, even today morning also, Vishnu was talking to me about this yesterday night. We were talking in WhatsApp. How do you homogenize section? What is the gradation that which dictates, demarcates one section to another section? This is again an area of research. I don't have an answer. And again, everybody said that we should take a sample. Take a sample, you take at the edge, left-hand side, right lane, left lane, middle, all you take. Now, between the chain edges kilometer, there's a variation. Between the cross section also, there is a variation. Which section, which gradation represent that kilometer is another question. So I'm only, my job is only as a teacher to pose questions, not to give an answer. I'm sure that my students will be able to answer. I think they used to tell that that driver will answer. Like that, I can tell my students will answer the questions. So this is something, some point that needs to be discussed and debated. What is that acceptable variation in the gradation, which we can consider as homogeneous? So this is the point to be raised. Saying gradation, well-graded material is critical, strong. How strong? Poor graded material, gap graded material, which will have high fines, means that they require a high cement content. So again, everybody made a mention that reclaimers are not crushers. Gradation has to be checked. Gradation is influenced by a type of reclaimer that is used, many factors that are to be considered. Again, what we have been talking all the speakers is that 4.5 to 7 MPa. Is it applicable to FDR or is it applicable to CTB? The second question is, are CTB and FDR one and the same? If you can answer this question, if they are one and the same, then 4.5 to 7 is okay. But now, what is the gradation? The CTB gradation is something different, as you can see there. The do-it-yourself FDR specification prepared by Mr. Guru Vittal is different. He also considered the PCA specification. With minimum dosage of cement, he has come out with that. So incidentally, what Vishnu had mentioned is that if you look at the gradation of CTB, up to 4.75, 100% can pass. What matters is, according to me, is 600 and 300 micron. Is that the gradation we are talking about? Anjan said that Anjan also made a presentation, IIT Guwahati specification. So is that working? Is it okay? How do you accept it? So the first requirement from the academic institution is that to decide, finalize, zoom down to the gradation for the FDR layer, knowing fully well the layer that we are going to use consists of old premix carpet, 1 or 2 layers, old WBM, maybe grading 1, grading 2, and grading 3, and in some cases, including subgrade. So again, another question comes, should I mill the subgrade or not? But what we found from all the service providers is that if they want their stabilizer to work, you need fines. If you need fines, you have to mill the subgrade. So finally, it all boils down to usage of that material. We are compromising on that. So that is what was told that we should find out where is the problem. So when it's rightly mentioned by Suresha, if your problem is only in the base course, mill only up to subgrade, base course. Why are you milling the subgrade? Incidentally, another question comes to the picture. Should the cement, what the dosage of cement and the stabilizer? I'm coming to the point. So again, Anjan also made a mention about this KSCSTE-NATPAC. So what do you consider this now? These are the 2 gradations of do it yourself. We have got a CTB, we got another gradation. Again, there are 4 gradations here. Which one to use? So I feel that academic institutions should now try with various gradations and come out with the most suitable gradation, including what Anjan has proposed as the IIT Guwahati gradation. So we have to find out first, fix the gradation of the material to be used for a full depth reclamation. Other point is that when there's a soil change, there's a change in material thickness of layer, how do you demarcate into homogeneous section? Second, how do you consider the quality of the base course and sub-base, as Vishnu was mentioning? Earlier we used even grade 1 with 75 millimeter above. We had boulders also. So when I visited UP, they removed physically the bigger aggregates and threw it out. When we were there, they were throwing it out. When we were not there, I do not know whether it will be thrown out or not. But that's what they were doing. So the mix consists of everything. It's a cocktail. WM grade 1, boulder, grade 1, grade 2, grade 3, PMC, subgrade soil also. Incidentally, another question also comes into picture. When in some cases, as I was mentioning, to make the stabilizer to work, you mill a subgrade. Milling a subgrade to even 20 centimeter. The world pavement has got only 30 centimeter. You already milled 20 centimeter. For this FDR pavement layer, the resultant remaining subgrade is only 10 centimeter. Will that work? I have no answer. Will it crack? Will it bend more? Will it deflect more? Will it crack? These are questions that are to be answered, both theoretically as well as by field. So again, as I was mentioning, the finished road level, Mr. Sigla is here. I think he will pose the question once again. Will or KIIFB also should be able to tell answer to this. Will the finished road level of a pavement, FDR pavement, should remain the same as it was before the construction of the FDR layer? Or will it increase? What are the incidental issues? If fresh materials are to be added, hot fresh material, how are you doing that? The issue is that FDR process will fluff the existing material, increase the volume. So pulverization, addition of cement also is required. So some fine material may have to be added. Perhaps if you add a shoulder material, additional material need not be added. So you compact to a higher density. But again, this is another question that has to be answered. Quality control test. Like sampling the soil for FDR, how do you ensure that the good construction quality is good? Okay, you do it. How do you check? You check the density or you take the UCS value. How many samples you can test? I can test 1 sample per kilometer, 2 samples, 3 samples. Okay. Now there's a variation between them. When you know at the end of 7 days or in their 28 days, assuming that the strength that you have achieved at the end of the 7th day or even 28th day is 3.5 MPa, 3 MPa. Will you accept? One is 3, other is 4, other is 5. How do you accept? You take the average. Will it crack when the value is low? These are other issues. So we should be able to decide what is the minimum strength that is required, how many samples are to be taken. Again, there was a question, I think Anjan also may be able to answer the question, how do you check the density of the compaction? Some people take the they take a sandporic cylinder and then test. Some take a nuclear density gauge, non-nuclear density gauge, use a geo gauge. Many things you can use. Somebody you have used is a lightweight deflectometer. So you can use any equipment, you get any number. But use of this NDT equipment will enable you to take more samples. With that, but finally, why I'm talking about this is that final acceptance should be based on statistical test, not based on 1 or 2 samples. You should, as Anjan had mentioned, you should find the mean, you have to find the standard deviation, you have to find the characteristic value. That characteristic value should not be lesser than the permissible value. The acceptance, this should be available in the contract. If you have over compaction, definitely there will be a raveling, premature failure. Curing is important. Many roads, even that UP road which I visited, we found that the traffic was flying. That's the only road leading to a village. We cannot close the road for 7 days. Then in that case, what is to be done? How to manage the traffic, how to cure, these are other issues. Other issues is quality control, ensure that uniformity of the cement. Again, how many samples to be taken? Again, Anjan was mentioning about the OMC. And if it rained, the moisture is, are we checking that? How do you check the moisture content at the site? This again, there's a lot of research that need to be carried out to find out the OMC at the site. Dosage of cement at the site. There's a variation. You take tray, weigh the tray. 10 samples, you get 10 numbers. Within the range, you have to find out what is the variability and ensure that uniformity of the mix. So calibrated density gauges becomes important. So the quality assurance finally should be based on this course. Nothing based on the laboratory density test either by nuclear or non-nuclear. I would prefer minimum of 10 samples, 10 course, any project. Minimum should be 10, preferably more. Find out the mean, find a standard deviation and find the characteristic value and mention that as the acceptable value before you accept or reject. So UCS value, again, if as Anjan was also mentioned, 2 to 2.75. I personally feel for low volume roads, maybe 3 MPa may be adequate, 4 to 4.5 to 7 may not be required. If that is the case, your dosage of cement will decrease, your cost will decrease. So these are other issues. Again, research institutions should do a reverse engineering for the desired performance. What should be the payment structure? For a pavement structure and a given strength, what should be the layer strength? To get the layer strength, what should be the dosage of cement? So we should work back. I always work back from performance to the design. I don't go forward chain from material to design to construction. I come from performance to design to the mix and then come back to the characterization of the material. So stabilizer. Again, cement enables strength gain in strength and as well as bonding. Stabilizer accelerate the strength gain with the heat of hydration. Higher strength we know results in cracking. Cement will work with a granular material. This again we told. So will all the stabilizer material ensure the material is friable? With a big question. Who decides the technology? For example, I think Mr. Dubey should be able to answer that question. Perhaps we will discuss it today afternoon again. He said that 5,000 kilometers or 4,000 kilometers being taken up with 9 different technologies. How do you decide this road, this is the technology to be adopted? This is something, again, these questions will arise in every state. First is, how do you decide this is a candidate project? Number 2, how do you decide this stabilizer to be used? Number 3, in UP, they have mentioned that minimum dosage of 4 to 5, 4.5 or 5% cement is needed. How do you decide that? Who decides the mix design? Finally, what strength you need? Then everything boils down to the dosage of the cement. So acceptance also we talked about. So ensure about the project selection we talked. Not all projects require FDR. The choice depends upon the severity and extent of distress. This again, we have to develop that. So that is one of the questions which I want to pose at 2 o'clock. How do you select a candidate project for FDR? That's the first question that has to be answered. What should be the subgrade strength that is needed before FDR becomes successful? Anjan made 40 MPa. What is the basis? How do you decide that? Third is, in case the height of depth of the water table is shallow, how do you do that? Should I increase the the formation subgrade level, or can I do any other treatment as a waterproof layer? Can I do capillary cutoff? Can I provide? Will it work? This is something research has to be carried out. So alternate rehabilitant actions are to be taken up before FDR is taken up if the subgrade is not higher than what is to be done. So issues with respect to stabilizer, as you can see here, is that almost all stabilizers require cement. Why? I have no answer. My question, object here is to pose questions. Why you need a cement? The incidental question is that if cement is required, will not cement be adequate? What is that magic the stabilizer is providing? Any commercial, any service provider will say that they will say it makes it friable, it makes flexible, it makes waterproof, all that they are telling. But nowhere what I request KIIFB also is that construct parallel sections with cement alone, so that at the end of few years, we will be able to compare the section with and without stabilizer. Again, they said yesterday, they also made a mention and was making a mention 100 ml of the liquid. I also saw in UP, they go climb up the container, water container, pour it there, mix it by hand. So it makes magic wonders. But how that magic takes place? This is something which academic institutions should play a role. I take about the quantity, I think Mr. Dubey was also mentioning, they know the dose length to be covered with the OMC. As the truck moves up to that level and if all the water is consumed, that means that much of water has been added and mixed. Now, right. Now to this water, I add about 100 ml of this magic liquid. When I add this magic liquid, how does it make it more flexible? This is R&D. We should do that R&D. Some are black, some are white. This is white powder. I don't know what is that white powder. So why I'm posing this question at this point of time is that, is there, you buy bitumen, you buy emulsion, you buy cement, anything you use, you test the material, does it meet the properties, physical requirement? What is that white? It's a stabilizer. What stabilizer? Some A, B, C, D. What are the properties of that? God only knows. Because it's a patented product. We do not know. Secondly, we do not know what the magic it plays. That also we do not know. I feel here a missing gap between academicians and practitioners. We should be able to tell what is it magic it plays. How does it make the material more compatible with the soil? How does it, what the mechanism of the strength gain? Improvement in durability. They say that improve the durability, Anjan made a mention, even without that also it is durable. So what is that extra durability that brings in? He talked about flexibility. How do you make it flexible? How do you quantify that flexibility? This is something that needs to be done. So I personally, what I need that there should be a mechanism of checking the quality of the stabilizer. That's what I'm coming to the bottom line. Other is that issues related to mixed design, gradation. If shoulder soil is mixed, what should be the optimal gradation? With different dosages, how do you arrive at the desirable gradation? What is the strength that is required? Can there be a minimum and maximum strength requirement? That's something that we need to arrive at. How many courses are to be taken? What statistical test acceptance, whether it should be mean plus 1 sigma, mean plus 2 sigma, or mean plus 2.65 sigma, 1.65 sigma. Again, these need to be arrived at based on the acceptable levels. How many days of curing is required? So part of subgrade is being mixed. In that case, how do you ensure that the subgrade, resultant subgrade is adequate? When you have the cement to be added, can the stabilizer alone play the magic? That's again we need to think. I study with cement, without cement, stabilizer alone with cement. So finally, what I'm looking at is an optimal gradation that is not coming up. So will one mix be adequate? So control section has to be constructed. Again, life expectancy varies, whether it is 7 to 10 years or 15 to 20 years, depending upon the overlay that we are constructing. So uniform density of compaction becomes an important factor. Anjan can deliver a talk for one day also on intelligent compaction. I think it's a long way to go. Whether it's suitable, how to go for it is something. Ensuring uniformity in the density of compaction is another factor. Anjan also had made a mention. He said that after 10 years, we may have to rehabilitate this road. I think we need not have wait for 10 years. There are already failed roads. There are already available FDR sections are constructed and cracked also. How are you going to rehabilitate this? This again is an R&D technology that has to be taken up here. Other issues, as I was mentioning, FDR, we are considering it in isolation. It is considered as a mix. It is not considered as a payment structure. So I think we need to look at as a payment component of the payment layer. It will eventually crack. Either isolated distresses, how to rectify it. This is another question that has to be answered. The other question is about the crack relieving layer. Is it required? Not required. If required, should it be a semi-layer? Should it be aggregate layer? And if aggregate layer, should it follow wet mix macadam gradation or different gradation? Or can I do a micro cracking? These are something R&D I personally feel should be taken up wherever the FDR projects are under implementation. So if you look at the key factors from USA, they found that Portland cement and emulsion are the two preferred stabilization techniques adopted. Cement stabilization was found to be effective. It is ineffective for a material with 100% wrap content. Emulsion worked well. So again, there's no one-size-fits-all design. Depending upon the gradation of the material, you have to choose that. As wrap content increased, emulsion content also needed for effective stabilization. So eventually, if you do not want crack, maybe bituminous emulsion may be better, foam bitumen may be better. Again, it depends upon whether you're milling the old BT and the granular layer, or are you going to mill the old bituminous layer, base coat, sub-base, and subgrade. So the technology that has to be adopted will vary. Again, depends upon the different distresses. Auger sampling they have adopted, but eventually, I think before you do the project selection for FDR, you should carry out an falling weight deflectometer study to find out is the payment structurally inadequate or adequate. So there should be also be allow some time for the shrinkage to occur after the curing. Low cement dosage is also recommended for minimizing the cracks. So finally, the point that needs to be discussion is that FDR is not the panacea for all types of distresses. It is just like giving a Dolo 650 or paracetamol for any fever. So that will not work. So depending upon the severity, extent of distresses, traffic level, subgrade condition, and the anticipated life, you have to choose whether FDR is the cost-effective solution. Every project is unique. You cannot copy. Just because UP have done it, does not mean that Kerala should copy the same. The soil in Kerala, rainfall in Kerala may be different from what is in UP. Technology can be learned, but you have to find a solution to your own problem. So mechanism of stabilization with cement and without cement has to be studied by the academic institution. Mixed design to be carried out on sampling. How to do the sampling is another issue, debatable. Perhaps we can discuss that in the afternoon. I personally feel that dosage of cement with and without stabilizer has to be optimized. Optimized to get the strength. What strength is another $1 million question. Will FDR with cement alone be adequate is something that needs R&D. There are other technologies like Zydex, Terazyme, bioenzymes have been used. How do they make the improvement in strength? They are waterproof layers, but will they improve the strength, durability, performance? I think we need a lot of research studies to be carried out. So it's a complex organic stabilizers are also used. Optimal dosage is not being studied. How to check the quality of stabilizer is a question which I am posing. I think maybe service providers should be able to tell me, convince me, how to check that product is as per the specifications. If there are some specifications, international specifications, either from FHWA or European standards or any standards for that matter, please show the standards. Tell me and convince me that this material that I am supplying to you meet these standards. I would like to see that. Again, control sections should be done with and without cement. Crack leaving layer, we have to discuss and decide what is the ideal crack leaving layer. The effectiveness of the pre-cracking is to be studied. Sampling is an issue that needs to be studied. Finally, how to relate the quality of construction to the performance. And to conclude, all projects or most of the projects will have a dispute between the client and the contractor and the concessionaire. There should be a dispute resolution mechanism so that the project is not stalled, is not withdrawn. I think we have to go a long way in ensuring this. I thank the several efforts that I have sent, and thank you very much. I am perfectly on time. Thank you. I think that I have posed a number of questions. There will be a number of questions that you need to be answered. So that's why we have reserved 2 hours exclusively from 2 o'clock to 4 o'clock. So keep all your questions ready. Go for lunch, come back at 2:15. We'll have session from 2:15 to 4:15. When all your questions will be discussed, I don't have an answer. All my students will answer. So we will discuss and find a solution to all your questions at maybe 2:15. Yeah.
Thank you, sir. Sir has thrown many questions which academicians can take, multiple PhDs can be produced. Thanks a lot, sir. Further, and they will continue during the open forum as sir has rightly pointed out. Over to you. Yeah.
Now I would like to invite Professor Dr. M.V.L.R. Anjanulu sir to hand over the moment to Veeraraghavan sir. Thank you, sir. Now we have a group photo session outside near the entrance. All are requested to join. And after that, we'll be having the open forum upstairs in the balcony. Thank you.